The space around us is not empty. It only looks that way because almost everything important here is too thin to see, too faint to glow, or too spread out for human senses to recognize as a place. If you could lift Earth out of daylight, remove the planets from the picture, turn down the stars until they were only cold points, and ask what kind of environment the solar system is actually moving through, the first answer might seem simple. Darkness, vacuum, silence. But that answer is wrong. Around the Sun there is a bubble. Outside that bubble there is interstellar gas. Around that gas there are streams, clouds, dust grains, magnetic fields, old heat, and the enormous remains of dead stars. The solar system is not sitting in a clean, empty chamber. It is moving through a layered neighborhood, and every layer tells part of a much older story. The closest layer is made by the Sun itself. The Sun does not only shine, it breathes outward. It releases a constant flow of charged particles called the solar wind, and that wind expands in every direction, pushing against the material between the stars. Where the solar wind still dominates, we are inside the Sun's territory. Where it weakens and interstellar space begins to press back, we approach one of the most important borders humans have ever measured, the edge of the heliosphere. That boundary is not a wall. A spacecraft does not hit it. Light does not bounce from it. You would not see a glowing shell around the solar system if you approached from outside. It is a change in conditions, a place where particles, magnetic fields, and pressure tell us that the Sun's influence has started to lose its grip. Voyager 1 and Voyager 2 crossed that boundary after decades of travel. They did not leave the entire solar system in the simple, popular sense, because distant icy objects and the long reach of the Sun's gravity extend much farther. But they did enter interstellar space, the region where the solar wind no longer flows as the dominant local environment. Their instruments found that the edge of our solar bubble is real, complex, and not quite like the smooth diagrams many of us grew up seeing. That alone would be enough to change how nearby space feels. The Sun is not just a lamp at the center of a planetary system. It is carrying a protective, magnetic, particle-filled bubble through the galaxy. But the deeper surprise is that the Sun's bubble is itself inside a much larger bubble. Our solar system sits within a vast, low-density region of the Milky Way known as the local bubble. It is not a perfect sphere. It is not a clean container. It is an irregular cavity in the interstellar medium, hundreds of light-years across, surrounded in places by colder gas and dust. The current understanding is that this cavity was likely excavated by a chain of supernovae, massive stars that lived, burned out, exploded, and pushed surrounding gas outward. That means our immediate cosmic neighborhood is not simply the place where Earth happens to be. It is the inside of an ancient event. The emptiness around us is partly inherited violence. This is the strange truth hidden inside the question. To ask what the space near us is like is not only to ask what lies beyond the planets, it is to ask what kind of galactic weather surrounds the Sun, what kind of invisible pressure shapes the heliosphere, what kind of fossil structure Earth is travelling through, and how far back the local darkness remembers. The first step is to let go of the idea that space is defined by what it lacks. On Earth, we are trained to understand places by what they contain: air, water, ground, trees, roads, buildings, heat, sound. Outer space seems like the opposite of place. It is defined by absence. No air to breathe, no ground to stand on, no sound to carry through the vacuum, no obvious horizon. But physicists and astronomers do not define space that way. To them, even an extremely thin environment is still an environment. A region can have temperature, density, pressure, magnetic direction, chemical composition, radiation, dust, motion, and history. A vacuum can still be structured. It can still have borders. It can still change over time. This is where nearby space begins to become unfamiliar. Inside Earth's atmosphere, a cubic centimetre of air contains more molecules than the mind can comfortably hold. In interplanetary space, that same volume may contain only a handful of particles from the solar wind. In interstellar space, It may contain even fewer atoms, but those few particles matter because the distances are immense. A thin gas spread across light years becomes a landscape. A faint magnetic field stretched across a star's path becomes a force that shapes a boundary. A small density difference, invisible at human scale, can decide how far the sun's influence extends. The neighborhood around us is not crowded, but it is not blank. It is a place where the sun pushes outward and the galaxy pushes back. That push is the first real image to hold in mind. Not Earth floating alone, not planets arranged like beads, but a star moving through the Milky Way while wrapped in its own wind. The heliosphere is often described as a bubble, and that image is useful as long as we do not make it too solid. It is better to imagine something more like a pressure-shaped envelope, stretched, distorted, and constantly renewed by the sun's activity. The sun emits solar wind at hundreds of kilometers per second. This stream carries charged particles and magnetic fields outward through the planetary system. It passes Earth, crosses the orbit of Mars, moves beyond Jupiter and Saturn, and keeps expanding until it can no longer simply push through the surrounding interstellar medium. Somewhere far beyond the planets, the solar wind slows, heats, and changes. Eventually, the heliopause marks the boundary where solar material and interstellar material meet. That boundary is one of the quietest dramatic places in science. Nothing explodes there. There is no visible cliff. Yet it defines the edge of the sun's immediate particle environment. It separates the solar wind from the interstellar medium. It is the skin of our local shelter. For most of human history, that skin was only an idea. We could infer it because the sun emits particles, because interstellar space contains material, and because two moving fluids must eventually meet. But inference is different from crossing. When Voyager 1 reached interstellar space in 2012, it gave humanity something extraordinary, a measurement from beyond the sun's wind. Voyager 2 followed in 2018, crossing a different part of the boundary and showing that this edge is not perfectly symmetrical. The Voyagers did not find a simple border. They found changes in particle populations, magnetic field behavior, plasma conditions, and cosmic ray intensity. They entered a region where the galaxy became more direct. Inside the heliosphere, the sun filters part of the incoming cosmic radiation. Outside it, interstellar conditions become more exposed. The spacecraft became tiny instruments listening to the environment just beyond the solar system's breadth. That phrase, interstellar space, can sound impossibly distant. It suggests the realm between stars, the great dark oceans of science fiction. But in physical terms, interstellar space begins surprisingly close compared with the scale of the galaxy. It begins just beyond the sun's protective bubble. The nearest interstellar environment is not millions of light years away. It is already being measured by human machines built in the 1970s. And yet even that is only the first surrounding layer. The material outside the heliosphere is part of what astronomers call the local interstellar medium. This is the thin mixture of atoms, ions, dust grains, plasma, magnetic fields, and radiation that fills the space between nearby stars. It is not uniform, it is patchy. It has clouds and cavities, warmer regions and hotter regions, denser threads and emptier volumes. The sun appears to be moving through a small local cloud, or a complex of nearby interstellar material, embedded within the broader local bubble. To a human imagination, a cloud sounds soft and visible. This cloud is neither. It is so diffuse that it would count as an excellent vacuum by Earth standards. But across astronomical distances, it becomes meaningful. It affects the heliosphere. It contributes atoms that drift into the solar system. It carries dust grains that can be detected by spacecraft. It shapes the background conditions through which the sun travels. This is the first major reversal of the story. The solar system is not a sealed container. It is more like a moving boundary zone. The sun's outward wind does protect and define the inner environment, but it does not isolate us completely. Interstellar atoms can enter. Galactic cosmic rays can penetrate, though their intensity is changed by solar activity. Dust from outside can pass through. The heliosphere is not a fortress. It is a living border. That border changes because the sun changes. The solar wind strengthens and weakens with the solar cycle. Solar storms disturb the flow. Magnetic fields shift and twist. The heliosphere breathes, expanding and contracting in response to conditions inside and outside it. The edge of the sun's influence is not a fixed line drawn in space. It is a negotiation. And on the outside of that negotiation lies the galaxy. Not the galaxy as a spiral photograph, not the Milky Way as a band of light over a dark sky, but the Milky Way as a local medium pressing against us, atom by atom. This is a different kind of astronomy. It does not begin with the most spectacular objects. It begins with the barely detectable material between them. The reason this matters is that the regions between stars are not passive. They are the raw material from which future stars form. They are the burial ground of old stars. They are stirred by explosions, heated by radiation, threaded by magnetic fields, and swept into shells. A galaxy is not just stars moving through nothing. It is stars constantly exchanging matter and energy with the space between them. Our neighbourhood is part of that exchange. The local bubble gives that exchange a shape. It is a vast cavity of relatively low-density material around the sun, with surrounding surfaces where gas and dust have been swept up. Modern mapping has made this structure feel less like an abstract guess and more like a three-dimensional neighbourhood. Nearby regions where stars are forming appear to lie along the bubble's surface, as if the expansion of the cavity helped gather material into places dense enough for new stars to be born. That is a profound shift in perspective. The space around us is not just the leftover gap between important things. It may be part of the reason some nearby important things exist. A chain of ancient supernovae likely pushed gas outward, carving a cavity and piling material into shells. In those denser regions, gravity could begin to take over. Gas compressed along the bubble's edges could collapse into new stars. The deaths of one generation helped arrange the births of another. And the sun is inside the cavity those deaths left behind. This does not mean the sun was born there. The sun is much older than the local bubble, about 4.6 billion years old, while leading models place the bubble's formation much more recently, on the order of tens of millions of years. The sun has been orbiting the centre of the Milky Way, passing through different galactic environments over time. At some point, it entered this cavity, or the cavity expanded around its path. Either way, our present address is temporary. That fact gives the story its deeper scale. Earth feels stable because human lives are short. Continents shift slowly. Stars seem fixed. The night sky appears permanent across a lifetime. But the sun is moving. The solar system is moving through local interstellar material. The local bubble itself has an origin, a structure, and an evolution. Our neighbourhood is not a place we own. It is a region we are passing through. To understand what the space near us is like, we have to replace the image of stillness with motion. The sun orbits the Milky Way at hundreds of kilometers per second, carrying the planets, asteroids, comets, dust, spacecraft, and all of human history with it. At the same time, nearby interstellar gas has its own motion. The heliosphere forms where these motions and pressures meet. It is shaped not only by what the sun emits, but also by what the sun is moving into. If the surrounding interstellar medium were denser, thinner, faster, slower, more magnetized, or differently oriented, the heliosphere could change. It might compress. It might stretch. It might alter how cosmic rays reach the inner solar system. Over deep time, as the sun passes through different regions, the space environment around Earth may change in subtle ways. This is where the story must be careful. It would be easy to turn this into false danger. It would be easy to say the solar system could plunge into a deadly cloud, or that ancient supernovae rewrote life on Earth in a simple, direct way. Some research explores possible connections between nearby astrophysical events and Earth's environment, but the causal chains are difficult, uncertain, and often debated. The honest version is more interesting than the exaggerated one. The local galaxy is not irrelevant to Earth, but it is not a simple disaster machine. It is a changing background condition. Earth is protected by many layers, its atmosphere, its magnetic field, the Sun's magnetic environment, and the enormous distances between stars. But protection is not the same as separation. The cosmic environment reaches us through particles, radiation, dust, and long-term changes in exposure. Our planet is local and galactic at the same time. This is the second reversal. Nearby space is not only out there, it is connected to here. Cosmic rays strike Earth's atmosphere. Solar storms disturb satellites and power systems. Interstellar atoms drift through the heliosphere. Dust from beyond the solar system can pass through the planetary region. The Sun's magnetic activity shapes the radiation environment in which spacecraft and astronauts operate. When we study the space around us, we are not studying an abstract emptiness. We are studying the outer conditions of our home. The difficulty is that most of those conditions are invisible. So scientists have had to build the neighborhood indirectly. They use spacecraft to sample particles. They use telescopes to map gas and dust. They use X-ray observations to infer hot plasma. They use polarized starlight to trace magnetic fields. They use stellar distances and motions to reconstruct the positions of clouds and young stars. They use energetic neutral atoms, particles created when charged particles exchange electrons, to image parts of the heliosphere that no camera can photograph in ordinary light. This is one of the most elegant ideas in the entire subject. To map something invisible, you do not always need light. Sometimes you need messengers. Particles arrive carrying direction, speed, energy, and history. A dust grain becomes a clue. A faint glow becomes a temperature estimate. A missing absorption line becomes a boundary. A star's motion becomes a clock that can be run backward. Piece by piece, the neighborhood appears not as scenery, but as evidence. And the more clearly it appears, the stranger our location becomes. We are not looking out from the center of a quiet room. We are inside a moving solar bubble, surrounded by interstellar weather, drifting through a cavity left by dead stars, while the galaxy continues to shape the conditions just beyond the reach of sunlight. IBEX, the Interstellar Boundary Explorer, helped make that invisible neighborhood less abstract. It did not fly to the edge of the heliosphere. It did not chase Voyager into the dark. Instead, it stayed much closer to Earth and watched for a special kind of messenger, energetic neutral atoms. These particles can be created when charged particles near the outer heliosphere exchange electrons with neutral atoms. Once they become neutral, magnetic fields no longer steer them in the same way. They can travel in straighter paths, carrying information from regions that ordinary cameras cannot see. In simple terms, IBEX turned particles into a kind of image. That image was not what scientists expected. The mission revealed a bright ribbon across the sky, a band of enhanced, energetic, neutral atom emission that did not fit the simplest models of the heliosphere. It was not a photograph in the familiar sense. It was not a glowing wall around the solar system. But it was a pattern, and patterns are how invisible structures begin to become real. The ribbon suggested that the local interstellar magnetic field was interacting with the heliosphere in a more organized way than earlier diagrams had implied. This is how the old smooth picture began to break. For decades, many drawings showed the heliosphere like a comet around the Sun, rounded in front, stretched far behind, with the Sun ploughing through interstellar gas and leaving a long trailing tail. That image was useful, but it was also too clean. Nature often accepts our first sketches only as invitations to revise them. The real heliosphere may be compressed, distorted, asymmetric, and shaped strongly by the magnetic field outside it. Some models suggest a more rounded or croissant-like structure rather than a simple comet tail. Others continue to test how solar wind, neutral atoms, charged particles, and magnetic fields combine at the boundary. The important point is not that one diagram has defeated all others. The important point is that the heliosphere is not a decorative outline. It is an active, physical system. Every mission adds a different sense to that system. Voyager touched the boundary directly, but only along two thin paths. IBEX sensed the boundary remotely through particles arriving from all directions. IMAP is designed to improve that kind of particle cartography, measuring energetic neutral atoms, solar wind particles, pickup ions, and cosmic rays with greater precision. Together, these missions turn the invisible edge of the Sun's influence into something measurable. That word, edge, must be handled carefully. The solar system has several edges depending on what one means. There is the region of the planets. There is the Kuiper belt. There are distant, scattered, icy bodies. There is the heliopause, where the solar wind gives way to the interstellar medium. There is the possible distant Oort cloud, a vast reservoir of icy bodies bound by the Sun's gravity far beyond the heliosphere. The Sun's gravitational influence reaches much farther than its particle wind. So when people say Voyager has left the solar system, the more accurate statement is that Voyager has entered interstellar space by crossing the heliopause. It has not escaped the Sun's gravity, and it has not passed beyond every object associated with the solar system. That nuance matters because the story is not about winning a race to a simple finish line. It is about learning that our home has more than one boundary. A planet has a surface, a house has walls, a country has borders on a map, but a star system has layered definitions. Gravity, particles, radiation, dust, and magnetic fields each draw a different kind of edge. The heliopause is one of those edges, and it is the one that tells us when the Sun's wind stops being the local dominant flow. The evidence for that edge came slowly. As Voyager 1 travelled outward, scientists watched the particle environment change. The spacecraft detected fewer particles associated with the Sun and more galactic cosmic rays from outside. Plasma measurements, magnetic field readings, and particle changes together revealed the transition. Voyager 2 crossed later, with different working instruments and a different trajectory, giving a second perspective. It confirmed that the boundary exists, but also showed that crossing it in one place is not the same as understanding the whole structure. This is an important lesson for the viewer. One measurement can be historic and incomplete at the same time. The same lesson applies to every map of local space. Our instruments do not reveal the neighbourhood all at once. They reveal it through overlapping methods, each with strengths and blind spots. Radio observations can trace certain forms of hydrogen. Ultraviolet absorption lines can reveal gas along the sightline to nearby stars. X-ray observations can suggest hot plasma. Dust maps can show where starlight is dimmed and reddened by material between us and distant stars. Gaia measures stellar distances and motions with such precision that the surrounding architecture of young stars and dusty regions can be reconstructed in 3 dimensions. No single method owns the truth. The truth appears where methods converge. This is why the local bubble became more than a vague cavity. Astronomers had long suspected that the Sun sat inside an unusually low-density region. The evidence included the distribution of nearby gas, soft X-ray emission, and the relative lack of dense interstellar material in some directions. But the bubble's shape, boundaries, and relation to nearby star formation remained difficult to pin down. We were inside the structure, looking through it. It was like trying to map fog from within the fog, except the fog was nearly empty and stretched for hundreds of light years. Gaia changed the scale of the map. By measuring the positions, distances, and motions of more than 1 billion stars, Gaia gave astronomers a more reliable 3-dimensional framework. When those stellar distances were combined with dust observations, the nearby interstellar medium could be mapped with much better depth. Young stars and star-forming regions could be placed in relation to the inferred surface of the local bubble. The result was not just a prettier map, it was a new causal picture. Many nearby stellar nurseries appeared to sit along the bubble's expanding shell. That turns the local bubble into a record of motion. If young stars are found along the shell, and if their motions can be traced backward, scientists can ask when and where the shell expanded, what groups of massive stars may have produced the supernovae, and how the cavity grew through time. The past is reconstructed from the present. Positions, velocities, ages, gas distributions, and models of expanding material. This is not certainty in the simplistic sense, it is evidence constrained by physics. The phrase carved by supernovae should therefore be heard with the right weight. It does not mean we watch the explosions happen. It does not mean every wall of the bubble has been measured perfectly. It means the observed structure is consistent with a sequence of powerful stellar events whose energy pushed gas away from the region around us. The models suggest a history that begins roughly tens of millions of years ago, recently in galactic time, but unimaginably ancient by human standards. The Sun, already billions of years old, found itself inside a much younger cavity. That mismatch is striking. Our star is not a newborn in this structure. It is an older traveller, passing through a younger wound. The planets were already ancient when the events that shaped the local bubble occurred. Earth already had oceans, continents, atmosphere, life, extinction, recovery, and long biological experiments behind it. Then, in the local region of the galaxy, massive stars ended their lives and changed the surrounding interstellar medium. From Earth's surface, none of that would have looked like a bubble forming around us. The distances were too large, the timescales too long, the evidence too subtle. But the structure remained, and now instruments can read it. This is the quiet power of modern astronomy. It does not only look for bright things, it learns to read absences. A lower density becomes a clue. A shell of dust becomes a clue. A line of young stars becomes a clue. A particle arriving from the edge of the heliosphere becomes a clue. The neighbourhood is not revealed by one dramatic image, but by the agreement of many faint signatures. And that may be more honest than a single image could ever be. A photograph can seduce the eye into thinking it understands. A reconstruction forces the mind to participate. The local bubble must be imagined from measurements, a cavity around us, irregular, expanding or evolving, connected to surrounding clouds. The heliosphere must be imagined from particles and fields, a solar envelope moving through the local interstellar medium. The two are not the same structure, but they belong to the same story of pressure, motion, and boundary. At the smallest of these large scales, the Sun creates a shelter by pushing outward. At the larger scale, dead stars created a cavity by pushing outward. The resemblance is not perfect, but the principle rhymes. Energy enters a medium, the medium responds, a boundary forms. Inside and outside become different. That principle is what turns the space near us from blankness into anatomy. The Sun's wind writes one kind of structure. Supernovae wrote another. Magnetic fields bend the paths of charged particles. Neutral atoms slip through more freely. Dust grains survive as tiny messengers of remote material. Cosmic rays arrive from violent processes across the galaxy and beyond, filtered but not erased by the solar environment. The instruments that reveal these things do not make nearby space less mysterious. They make the mystery more precise. Instead of asking, vaguely, what lies beyond the planets, the question becomes sharper. What is the true shape of the heliosphere? How does the local interstellar magnetic field wrap around it? How porous is the boundary? How does solar activity change the flow of particles? What exactly is the Sun moving through right now? Where are the edges of the local bubble? How many supernovae helped create it? How does its shell relate to nearby star formation? Those are not trailer questions. They are working, scientific questions. And because they are real, they have a different kind of pull. They do not ask us to believe that space is hiding a secret. They ask us to accept that even our own address is unfinished knowledge. The space nearby is being mapped while we are inside it. To build the world around us correctly, the scale has to slow down. Not because the story becomes smaller, but because nearby space is easy to misunderstand when we rush through it. A diagram can draw the Sun, the planets, the heliosphere, and the surrounding bubble in a few neat lines. But the real environment is not neat. It is layered so thinly that almost every part of it would feel like nothing, while still being physical enough to shape the motion of particles across billions of kilometers. Begin close to Earth. Below us, the atmosphere is dense, warm, chemically rich and noisy. It holds clouds, weather, pressure, and sound. Above us, that air thins gradually until the idea of a clean boundary becomes more convenient than literal. There is no sharp surface where Earth's atmosphere simply ends. It fades upward. Satellites move through the outermost traces of it. Charged particles gather and flow along magnetic field lines. Auroras appear when solar particles interact with gases high above the surface. Already the first lesson is present. Space does not begin with a war. It begins with a fading. Earth's magnetic field stretches outward into a region called the magnetosphere. This is not a solid shield, but it matters. It helps deflect many charged particles from the solar wind, shapes radiation belts around the planet, and forms a long magnetotail away from the sun. When solar storms arrive, this system can be disturbed. Energy moves through it, particles accelerate, auroras brighten. Technology can be affected. Power systems, satellites, radio communication, and navigation systems can all feel the consequences of changes in near-Earth space. So even before leaving the neighbourhood of our planet, the old image of emptiness has already failed. Near-Earth space is a working environment. It has weather, though not weather made of rain and air. It has storms, though not storms with clouds. It has pressure and flow, though not the kind skin can feel. Beyond Earth's magnetic shelter, the planets are immersed in the solar wind. This flow comes from the Sun's outer atmosphere, the corona, and expands outward through interplanetary space. It is made mostly of charged particles, especially protons and electrons, carrying the Sun's magnetic field with it. The solar wind is not perfectly steady. It changes with the solar cycle, with coronal holes, with eruptions, with the rotating structure of the Sun itself. The result is that interplanetary space has texture. It contains streams of faster and slower solar wind. It contains coronal mass ejections, huge eruptions of plasma and magnetic field that travel outward and can strike planetary environments. It contains dust, much of it from comets and asteroids, forming a faint zodiacal cloud that can scatter sunlight. It contains cosmic rays from beyond the solar system, their arrival shaped partly by the Sun's activity. It contains the magnetic field of the Sun, drawn outward and twisted into a spiral by the Sun's rotation. That spiral matters because the Sun is spinning while the solar wind moves outward. The magnetic field carried by the wind does not extend in straight radial lines like spokes from a wheel. It curves into what is called the Parker spiral, a vast magnetic pattern filling the heliosphere. Planets move through this structure. Charged particles follow and scatter along it. Spacecraft must travel through it. The solar system is not only gravitational architecture, it is magnetic architecture too. This is why the Sun should not be imagined only as a bright centre. It is the source of a whole environment. Mercury sits deep inside that environment, close enough for solar radiation and particles to dominate its exposed surface. Venus, wrapped in thick atmosphere but lacking an Earth-like global magnetic field, interacts directly with the solar wind in a different way. Earth has its magnetosphere. Mars, with no strong global magnetic field today, presents another kind of interaction, its atmosphere exposed in ways that matter for long-term atmospheric loss. Jupiter's magnetic field creates a vast magnetosphere of its own, a powerful structure embedded inside the Sun's larger flow. Saturn, Uranus, and Neptune carry their own magnetic environments into the distant solar wind. Each planet is not simply orbiting in empty space. Each is negotiating with the Sun's outflow. Even small bodies reveal the solar environment. A comet approaching the Sun warms and releases gas and dust. Sunlight pushes the dust into one kind of tail. The solar wind and magnetic field shape ionized gas into another. The comet becomes visible evidence of flows that are usually invisible. It is a temporary drawing made by the local conditions. Farther out, the sunlight weakens, but the solar wind continues. The planets thin out behind us. The Kuiper belt begins, a broad region of icy bodies beyond Neptune, including Pluto and countless smaller objects. These worlds are cold, ancient, and slow, preserving clues from the early solar system. But even here, the Sun's particle influence has not ended. The heliosphere extends far beyond the orbit of Pluto. Distance changes the character of the environment. The solar wind spreads out as it travels, its density drops, its interaction with interstellar material becomes more important. The outer heliosphere is not simply the same wind continued forever. It is a region where the solar flow begins to lose the clean dominance it had near the planets. Eventually, the solar wind reaches the termination shock. The word shock may sound violent, and physically it is a real transition, but it is not an explosion waiting for a spacecraft. It is a place where the supersonic solar wind slows down as it begins to feel the pressure of the interstellar medium ahead. The flow changes, particles heat, conditions become more turbulent. Beyond that lies the heliosheath, a broad outer region where the slowed solar wind is compressed and disturbed before giving way at the heliopause. The heliopause is the boundary most often used to mark entry into interstellar space. But even there, the environment is not simple. Magnetic fields drape and bend, particles cross and interact. Neutral atoms can move through more freely than charged particles. Cosmic rays increase beyond the solar shield. The transition is a region of physics, not a painted line. Voyager 1 crossed this boundary first. Voyager 2 crossed later in another direction. Both crossings changed the way nearby space could be described because they turned a theoretical edge into measured conditions. But the two spacecraft did not encounter identical circumstances. That difference matters. It reminds us that the heliosphere is three-dimensional, time variable, and shaped by conditions that no single path can fully capture. Outside the heliopause, the local interstellar medium begins. This does not mean the spacecraft entered a rich fog. The density is still extraordinarily low. A human body would not feel wind there. A cup open to that space would not fill with gas. But instruments can detect what the body cannot. They can measure plasma waves, magnetic fields, particle energies, and changing cosmic ray populations. They can hear the local medium through physics rather than sound. Here the environment becomes more galactic. The particles are no longer mainly part of the sun's wind. The magnetic field is no longer carried outward from the sun in the same way. The surrounding gas belongs to the space between stars, shaped by nearby stellar history, by older explosions, and by the larger circulation of the Milky Way. The sun's path through this material creates a continual interaction. The heliosphere is shaped by what it moves through, just as a boat's wake depends on the water. But this comparison should not be pushed too far. Interstellar space is not water. It is too thin, magnetized, partly ionized, and full of particle interactions that have no everyday equivalent. Still, the underlying idea helps. Motion through a medium gives a system a front, a response, and a shape. The medium outside is not uniform. The sun appears to be in or near a small, warm cloud of interstellar material within the local bubble. Nearby, other small clouds and flows have been identified through the absorption of starlight. These clouds are not fluffy objects with sharp edges. They are regions where temperature, density, velocity, and ionization differ from neighboring regions. They are known because light from nearby stars passes through them and carries away faint signatures of the atoms along the path. A star becomes a background lamp. The gas between us and that star leaves fingerprints in the light. By comparing many stars in many directions, astronomers reconstruct the invisible distribution of material. This is how the local neighborhood begins to gain depth, not as a photograph, but as a set of distances and intervening traces. Some directions show more dust, some show less. Some reveal gas moving at one velocity, some another. Certain stars appear reddened or dimmed because dust lies between them and us. Others shine through cleaner lines of sight. The result is unevenness, cavities, clouds, sheets, tunnels, and shells. The local bubble is the largest nearby expression of that unevenness. From the inside, it would not look like a glowing cavern. A human eye placed in interstellar space would still see darkness and stars. The bubble's presence is not visual in that simple way. It is inferred from the relative absence of dense material, from maps of dust, from the distribution of nearby gas, from emissions associated with hot plasma, and from the arrangement of young stellar regions around us. This is what makes the environment so strange. It can be physically real without being visually obvious. A person standing on Earth sees the night sky as a surface of points. A telescope sees more points. A spacecraft samples particles along a path. A survey measures stellar positions and distances. A model connects the pieces into shape. The local environment is a place that had to be assembled in the scientific imagination, from instruments that each perceive only one aspect of it. And when assembled, it gives our surroundings a new identity. We live inside a low-density cavity, likely carved by explosions that happened millions of years ago. Around parts of that cavity, colder gas and dust form denser regions. Along those regions, nearby stars have formed or are forming. Inside the cavity, the sun carries its own smaller, wind-blown bubble. Inside that bubble, Earth carries its magnetic shelter. Inside that shelter, a thin atmosphere allows human beings to mistake their immediate world for the whole definition of place. The nesting is almost too large to feel at once. But it is the truth of our proximity. Nearby space is not a blank interval between Earth and the stars. It is a sequence of fading protections, interacting flows, old explosions, and invisible boundaries. It is quiet only to ears. It is dark only to eyes. To instruments, it is full of direction. The first major mechanism is pressure. That sounds almost too ordinary for a subject this large. Pressure belongs to weather maps, bicycle tyres, deep water, mountain air. It feels like something close to Earth, something that needs atmosphere or liquid or touch. But pressure is more general than that. Wherever particles move, wherever fields carry energy, wherever radiation flows, something can press against something else. The pressure may be unimaginably faint, but over astronomical distances, faint forces can draw enormous shapes. The heliosphere exists because of pressure balance. The sun sends the solar wind outward. That wind has mass, speed, and magnetic structure. It pushes. The local interstellar medium outside the solar system also has pressure, from its sparse gas, its charged particles, its magnetic fields, and its own motion relative to the sun. It pushes back. The boundary between them forms where neither side can simply ignore the other. This is not a battle with a clean winner. It is an adjustment. Closer to the sun, the solar wind dominates. It expands outward freely enough that the planets live inside a solar environment. At Earth, we feel its presence indirectly through auroras, geomagnetic storms, and the space weather that can disturb satellites. At Jupiter, it encounters a huge magnetic system. At Neptune, it is weaker, more spread out, but still part of the sun's extended influence. As it travels farther, the solar wind thins. Imagine a crowd leaving a stadium through every exit at once. Near the stadium, the flow is dense. Far away, the same people are spread across a much larger area. The solar wind behaves differently in detail because it is plasma and magnetic fields rather than people, but the basic intuition helps. As the wind expands through space, its density drops. Its ability to dominate the environment gradually weakens. Eventually, the surrounding galaxy matters more. The solar wind does not stop because it runs out of distance. It changes because it meets resistance. The local interstellar medium is sparse, but it is not nothing. It has atoms, ions, electrons, dust, magnetic fields, and motion. It is thin enough to seem irrelevant by human standards, yet large enough and persistent enough to shape the sun's outer boundary. The first major transition is the termination shock. The solar wind, which has been travelling faster than the speed at which disturbances can move through that plasma, slows abruptly as it feels the pressure ahead. The word shock describes a real physical transition in the flow. It does not mean fire or explosion. It means the plasma reorganizes. Speed, temperature, density, and magnetic field behavior shift. The solar wind becomes slower and hotter, entering the disturbed outer region called the heliosheath. In the heliosheath, the sun's wind is no longer a clean outward stream. It is compressed, deflected, and mixed into a complicated boundary region. Particles interact, magnetic fields bend. Neutral atoms from the interstellar medium pass through and exchange charge with solar particles. Some of those interactions produce energetic neutral atoms that can fly back toward the inner solar system, where instruments can detect them. This is how pressure becomes visible without light. The heliopause lies beyond, marking the place where the solar wind gives way to the interstellar medium. Again, The image of a wall is misleading. The heliopause is better understood as a surface of changing dominance. On one side, the particles and magnetic field mostly belong to the sun's outflow. On the other, the surrounding interstellar environment takes over. There may be leakage, turbulence, and complex layering. Boundaries in plasma rarely behave like the borders in school diagrams. The deeper mechanism is not simply that the sun blows a bubble. It is that the sun continuously maintains one. If the solar wind changed strongly, the heliosphere would respond. During periods of stronger solar activity, the inner particle environment changes. Solar eruptions send disturbances outward. Over time, those disturbances travel through the heliosphere and can affect conditions far from the planets. The boundary is not frozen. It is a moving result of ongoing input. The interstellar side is also not fixed. The sun is moving through the galaxy, and the local gas has its own motion. That means the heliosphere is shaped by relative flow. The sun encounters the local interstellar medium from a particular direction, creating an upstream side and a downstream side. The interstellar magnetic field influences how charged particles move and how the boundary drapes around the heliosphere. Neutral atoms behave differently because they are not tied to magnetic field lines in the same way. This difference between charged and neutral particles is one of the keys to the whole story. Charged particles, such as protons and electrons, respond strongly to magnetic fields. They spiral, scatter, and follow field structures. Neutral atoms do not feel magnetic fields directly in the same way. They can slip across regions that charged particles cannot cross as easily. But neutral atoms can become charged if they are ionized by sunlight or exchange electrons with other particles. Once that happens, the sun's magnetic environment can pick them up and carry them along. These are called pickup ions, and they help scientists understand the interaction between solar and interstellar material. A boundary that sounds simple becomes alive with exchange. Some particles come from the sun and are slowed, heated, and diverted. Some come from interstellar space and enter the heliosphere. Some change identity through charge exchange. Some become messengers that travel inward. Some cosmic rays from the galaxy are partially shielded by the heliosphere, while others penetrate toward the inner solar system. The border is not a locked door. It is a filter, a mixer, a translator. This is why calling the heliosphere a protective bubble is useful but incomplete. It does protect. It reduces the intensity of some incoming galactic cosmic rays. It shapes the radiation environment around the planets. It separates the inner solar system from direct exposure to the full local interstellar medium. But it is not absolute protection. Cosmic rays still reach Earth. Interstellar atoms still enter. The galaxy still touches the solar system. The shield is porous. That porosity matters because it gives nearby space its character. We live inside a solar-controlled region, but not inside a sealed room. The sun changes what reaches us. It does not erase the outside universe. The local environment is always present, pressing faintly but persistently on the outer edge of the sun's domain. To understand this physically, imagine standing in a cold wind while holding a warm breath in front of you. The breath expands, curls, mixes, and disappears into the surrounding air. Now remove air thick enough to feel, replace it with plasma thinner than any human vacuum, stretch the interaction across billions of kilometers, add magnetic fields, supersonic flow, cosmic rays, and particles that can change charge, and the analogy breaks. But the basic idea remains. An outflow meets an environment, and the meeting creates structure. The heliosphere is that meeting. Its size is not determined only by the sun. It is determined by the relationship between the sun and its surroundings. A stronger solar wind could push the boundary outward. A denser or faster interstellar medium could compress it inward. A differently oriented magnetic field could distort it. This means the solar system's protective envelope is partly a record of the local galaxy. The edge of the sun tells us about the space outside it. That is a beautiful inversion. We cannot easily sample the local interstellar medium in every direction, but we can study how the heliosphere responds to it. The shape of the bubble, the distribution of energetic neutral atoms, the intensity of cosmic rays, the flow of interstellar helium, the behavior recorded by Voyager. All of these become clues about the medium pressing against us. Pressure balance also explains why diagrams can mislead. A simple round bubble suggests equal pressure in every direction, but the sun is moving. The interstellar medium has a magnetic field. The solar wind is not identical at all latitudes. The sun's activity changes over time. The heliosphere is probably not a perfect sphere, and may not even resemble the classic long-tailed comet shape in every respect. Its true shape emerges from competing influences that vary with direction and time. This is not a minor technical correction, it changes the emotional image of home. The solar system is not wrapped in a perfect glass sphere. It is surrounded by a restless, uneven, breathing envelope, formed by the sun's constant outflow and sculpted by the galaxy's faint pressure. Its boundary is far away, but not abstract. It is the place where our star's environment becomes part of a larger environment. It is the seam between solar weather and galactic weather. And that seam is not silent. It speaks in particle counts, magnetic fields, plasma waves, cosmic ray intensities, and neutral atoms that arrive from the edge carrying the memory of collisions. It speaks to spacecraft moving outward, and to instruments near Earth reading the sky in particles instead of light. It speaks in changes too small for the senses and too large for the imagination. The first mechanism, then, is not emptiness, it is contact. The sun pushes. The galaxy pushes back. Between them, our local shelter takes shape. The second major mechanism is excavation. If the heliosphere is made by the sun pushing outward right now, the local bubble was made by stars pushing outward in the past. Not gently, and not in the same steady way as the solar wind. The larger cavity around us was shaped by massive stars that ended their lives violently, injecting energy into the gas between stars and forcing the surrounding medium to rearrange. A supernova is not just a bright death. It is an event that changes a neighborhood. When a massive star explodes, its outer layers are blasted into space at enormous speeds. The shockwave expands into surrounding interstellar gas, heating it, compressing it, stirring it, and pushing it aside. One supernova can carve a cavity. Several supernovae from stars born in the same loose association can combine their effects. Their shocks overlap. Their hot interiors merge. Their expanding shells sweep up more gas. Over millions of years, what began as separate explosions can become a shared structure, a superbubble. The local bubble appears to be one of these nearby structures, a cavity in the interstellar medium large enough to surround the sun, yet local enough to be mapped beside nearby star-forming regions. Its interior is relatively low in density. Around it, colder gas and dust are arranged in denser structures. This is what pressure-driven expansion tends to create. Energy pushes outward, material is displaced, the inside becomes thin, the boundary becomes richer. This is the second way that emptiness becomes misleading. The local bubble is not empty because nothing happened there. It is emptier because something did. The old stars that helped create it are gone. Their original forms are no longer visible. But the gas remembers through shape, temperature, density, motion, and the positions of young stars that formed later along the surrounding material. A human eye cannot see that memory directly. It sees constellations, bright stars, the pale band of the Milky Way. The deeper structure has to be reconstructed. That reconstruction turns nearby space into a fossil. Not a fossil made of bone or shell, but a fossil made of absence. A region with less gas than expected. A surrounding arrangement of dust. A pattern of young stars. A history inferred from motion. The cavity itself is evidence that energy once passed through this part of the galaxy and changed it. The interstellar medium is not a smooth fog. Some regions are cold and dense, some are warm and diffuse, some are hot and ionized, some are threaded by magnetic fields. Gas clouds collide, stretch, cool, heat, and fragment. Stars form where gravity can overcome internal pressure, turbulence, and magnetic support. Massive stars then reshape the very environment that made them. Before they explode, they already affect their surroundings. Their radiation heats nearby gas. Their stellar winds blow cavities. They erode the clouds from which they were born. Then, when they die as supernovae, they add a final violent push. The result is not a clean explosion in empty space. It is an explosion into a medium that already has structure. That is one reason the local bubble is irregular. It was not inflated inside a perfect container. It expanded through uneven material. In some directions, the shock may have travelled farther. In others, denser clouds may have slowed or shaped it. Magnetic fields may have guided or resisted the flow. The actual shape is not a smooth sphere, but a complicated local cavity in a complicated galactic disk. This matters because diagrams often make the universe look too tidy. A clean circle can teach the basic idea, but it can also erase the truth. Real cosmic structures are shaped by encounters. Pressure meets density, shock meets cloud, wind meets field, expansion meets resistance. The local bubble is not a perfect object around us. It is a record of how energy moved through an uneven medium. And the consequences did not stop with making an empty region. As the bubble expanded, it swept gas and dust outward. Swept-up material can gather into shells or walls. If parts of those shells become dense and cool enough, they may become places where stars can form. It suggests that the same process that cleared the interior may have helped organize the conditions for new stars along the outside. The cavity and the nurseries belong to the same story. In ordinary language, destruction and creation sound like opposites. In the interstellar medium, they can be phases of one process. A supernova can disperse gas in one place and compress it in another. It can end the life of one star while helping prepare conditions for later stars. Its shock can heat material, but also drive structure into clouds. The galaxy does not treat death as an ending, it treats it as redistribution. That redistribution has no intention, but it is productive in the physical sense. It moves matter, it changes density, it seeds turbulence, it injects heavier elements, it turns smooth regions into shaped ones. Over time, those shaped regions can become new stellar environments. This is why the local bubble should not be treated only as a whole. It is a system of inside and edge, absence and accumulation, old heat and cold gas, vanished stars and forming stars. Its emptier interior makes sense only together with the swept-up surroundings. The space around us is therefore not merely the aftermath of explosions, it is part of an ongoing galactic circulation. The Sun's position inside this structure is almost accidental from a human point of view, but scientifically rich. The Sun did not form in the local bubble. It is far older than the bubble's likely age. It was already carrying its planets around the galaxy when the massive stars that shaped our local cavity were born, lived, and died. The local bubble is simply the environment we occupy now. That temporariness matters. If we could follow the Sun for tens of millions of years, the cosmic neighborhood would not remain the same. The Sun would move relative to local clouds. The heliosphere would respond to new external conditions. The local bubble itself would evolve, merge, cool, or be reshaped by later events. Home, on galactic timescales, is not fixed ground. It is passage. Excavation adds time to pressure. Pressure explains the boundary around the Sun right now. Excavation explains why the larger space around the Sun has its present character. The heliosphere is maintained by present solar wind. The local bubble was opened by past stellar violence. One is current weather, the other is geological history, if the galaxy can be allowed its own geology. The comparison is useful because geology teaches us to read landscapes as records. A canyon records erosion, a crater records impact. In the same way, a low-density cavity records energy injection, a shell of gas records swept-up material, a line of young stars can record where conditions became dense enough for gravity to begin again. The local bubble is the landscape of the invisible. A region can be hot, low density, magnetized, expanding, cooling, leaking, and interacting with neighboring cavities, while still looking to our eyes like nothing at all. We expect important things to appear important. Nearby space does not obey that expectation. Its importance is distributed across particles and light years. The ancient event becomes the present condition. That is the emotional precision of the local bubble. It is not frightening in the cheap sense. It is unsettling because it means the calm darkness around us is not primordial stillness. It has been worked on. It has been cleared, heated, compressed, and rearranged. The night sky may feel timeless, but the space between the stars has a recent memory by galactic standards. And inside that memory, the sun carries Earth forward. Scale changes the meaning of everything. A boundary that feels remote to a spacecraft can be almost nearby to a star. A cavity that would swallow every human journey ever attempted can still be a small feature in the Milky Way. A particle so rare that it seems irrelevant inside a laboratory can become important when stretched across a distance measured in light years. Nearby space forces the mind to keep changing rulers. The heliosphere is the first scale that breaks ordinary intuition. Earth is about 1 astronomical unit from the Sun, 1 Earth-Sun distance. Neptune is about 30 astronomical units away. Pluto's orbit carries it through a distant, tilted path beyond Neptune. The Kuiper belt spreads still farther, filled with icy bodies left from the solar system's formation. But the heliopause, the boundary crossed by the Voyager spacecraft, lies more than 100 astronomical units from the Sun, and its exact distance changes with direction and conditions. That is already enormous. Light from the Sun reaches Earth in a little over 8 minutes. It takes hours to reach the outer planets. A radio signal to Voyager takes many hours to arrive. Commands sent from Earth do not touch the spacecraft instantly. They cross a widening emptiness, reach a machine built by human hands, and then the answer comes back through the same dark distance. Yet on the scale of the nearest stars, the heliosphere is tiny. The nearest known stellar system, Alpha Centauri, lies more than 4 light-years away. 1 light-year is about 63,000 astronomical units. The heliosphere, immense by spacecraft standards, is only a small pocket around 1 star. Between the Sun's boundary and the next stellar system lies interstellar space. Thin, cold in the human sense, magnetized, and almost completely beyond direct human reach. This is the first emotional contradiction of scale. The edge of the Sun's wind is so far that only 2 working spacecraft have crossed it after lifetimes of travel. But compared with the distance to the next star, it is still almost our doorstep. The local bubble expands the scale again. Its full extent is not a simple fixed number, because it is irregular and its edges are not hard walls, but it is commonly described as a structure hundreds of light years across, roughly on the order of 1,000 light years in its widest dimensions. That means light itself takes centuries to cross the cavity around us. Generations of human civilization could rise and fall while a beam of light moved from one side of the local structure to another. And still, in the Milky Way, this is local. The galaxy is roughly 100,000 light-years across. It contains hundreds of billions of stars, huge reservoirs of gas and dust, spiral structures, stellar nurseries, old clusters, dark clouds, superbubbles, magnetic fields, and a central region dense with motion and energy. Against that scale, the local bubble is not the universe. It is not even the galaxy's dominant feature. It is a neighborhood cavity, one room in an enormous, moving, self-reworking city of stars. This is where the title becomes more powerful. Immediate proximity does not mean small. It means surrounding. It means the environment close enough to define our cosmic address. The local bubble is immediate in the same way weather systems are immediate from a planet's point of view, even if they stretch beyond the horizon. We cannot touch the bubble's walls. We cannot see them with our eyes, but we are inside the region they define. Scale also changes the meaning of time. The solar wind crosses the distance from the Sun to Earth in days. Solar storms can affect near-Earth space on human timescales. The solar cycle rises and falls over roughly 11 years. A spacecraft can spend decades reaching the outer heliosphere. The local bubble, by contrast, formed over millions of years. The Sun orbits the Milky Way over hundreds of millions of years. The environments through which the Sun travels change on timescales so long that no civilization can watch the full cycle unfold. But Earth has existed long enough to pass through many such conditions. Our planet is about 4.5 billion years old. The Sun has orbited the galaxy many times during that span. It has not remained in one static interstellar setting. It has moved through changing densities, clouds, radiation fields and stellar neighborhoods. The present local environment is not the permanent condition of the solar system. It is one chapter in a much longer orbital history. This does not mean every change was catastrophic. The galaxy is not constantly throwing disasters at Earth. Most of the time, distance is protection. Space is vast. Dangerous stellar events must be close enough, energetic enough, and timed in the right way to matter strongly. But it does mean Earth's surroundings are not eternally identical. The background through which the solar system moves has a history, and future conditions will not perfectly match the present. The solar system is both stable and in motion. That combination is hard to hold. We experience stability because gravity keeps Earth in orbit, because the Sun rises reliably, because the stars change so slowly that a human life barely notices their drift. But the whole system is moving through the galaxy. The familiar sky is not a fixed dome. Nearby stars have their own motions. Clouds of interstellar gas drift and change. Cavities expand, cool, merge, and fade. On enough time, the neighborhood rearranges. The local bubble may have begun forming around 14 million years ago in leading reconstructions. That is recent compared with the age of Earth, but ancient compared with humanity. 14 million years ago, no human eyes watched the sky. Mammals had already inherited the planet after the dinosaurs' extinction, but the human lineage was still far from becoming what it is now. While life on Earth continued its slow experiments, massive stars in our galactic neighborhood were ending and reshaping the medium through which the Sun now travels. That gives nearby space a strange age. It is young compared with Earth. It is old compared with us. It is a recent scar on an ancient system. The distances inside this story also change how we understand evidence. A spacecraft crossing the heliopause gives a direct measurement, but only along one path. A telescope mapping dust across hundreds of light years gives broad structure, but indirectly. Gaia measuring stellar positions offers a three-dimensional framework, but the gas and dust still have to be inferred and modelled. The larger the scale, the more the evidence becomes a reconstruction from many partial views. This is why scientific uncertainty grows with the map. Not because scientists are guessing wildly, but because the object is enormous, diffuse, irregular, and observed from the inside. To know the exact shape of the local bubble, one must know where gas and dust are distributed in 3 dimensions, how hot plasma fills the cavity, how magnetic fields thread it, how it connects to nearby structures, and how all of that changed over time. Each part can be studied, none is trivial. The same is true of the heliosphere, only on a different scale. Voyager gave direct crossings. IBEX gave remote particle maps. IMAP adds sharper particle measurements. Models connect these data to the solar wind, the interstellar magnetic field, and neutral atom flows. But the heliosphere changes with solar activity, and the measurements are limited by where our instruments are. Its true shape is not a museum object, it is a living boundary. Scale also changes danger into perspective. A supernova helped carve the local bubble, but that does not mean a supernova is happening next door now. The cavity is a remnant of past energy, not a current explosion. The heliosphere filters cosmic rays, but that does not mean it blocks all radiation. Interstellar space contains gas and dust, but not enough to behave like air. Nearby space is active, but not theatrical. It is powerful in the way deep systems are powerful, quietly, continuously, across scales too large to notice directly. That quiet power may be the hardest thing to communicate. The Sun does not announce that it is carrying a bubble through the galaxy. The local bubble does not glow above us as a dome. The interstellar medium does not sweep past Earth like weather we can feel. But the structure is there, and its effects are measured. the invisible becomes real through consequence. A particle count changes. A cosmic ray intensity rises. A dust map reveals a wall. A star's motion points backward to a formation site. A faint X-ray glow suggests hot plasma. An energetic neutral atom arrives from the outer boundary. Each clue is small. Together, they make an environment. This is the scale escalation the viewer needs to feel. Not bigger objects for their own sake, but larger contexts that change the meaning of the smaller ones. Earth is not just a planet under a sky. It is a planet inside the sun's magnetic influence. The sun is not just a star with planets. It is a moving wind source inside interstellar gas. The heliosphere is not just a boundary. It is a response to the local galaxy. The local bubble is not just a cavity. It is the afterimage of stellar death and a possible organizer of nearby stellar birth. Every layer changes the layer inside it. And yet none of these layers was built for us. That is part of the coldness of the realization. The solar system happens to be here now. Earth's life happens to look out from inside this arrangement. The surrounding structure is not hostile in a dramatic way, not protective in a purposeful way, not meaningful because it recognizes us. It is meaningful because it is real, and because understanding it makes our home more precise. The space in our immediate proximity is immense, thin, old, changing, and layered. It is close enough to define our surroundings and large enough to make human distance meaningless. It is quiet enough to seem empty and active enough to shape the boundary of the sun. It is local, but not small. And once that scale is understood, the next question becomes unavoidable. If even nearby space is this structured, what else has the idea of emptiness been hiding? The deeper reversal is that the local bubble is not only a remnant of destruction, it may also be a birthplace arrangement. At first, the idea of a supernova-carved cavity feels like a story of removal. Massive stars explode, shock waves expand, gas is swept away, the interior becomes thin. The region around the sun becomes an evacuated space, a hollow left behind by events too powerful to imagine from the surface of Earth. That image is true enough to begin with, but it is incomplete. Because when gas is pushed away from one place, it does not vanish. It piles up somewhere else. Around parts of the local bubble, interstellar material has been gathered into denser walls, ridges, and clouds. These surrounding regions contain gas and dust, and in some places, they are connected with nearby star-forming complexes. The same expansion that helped clear the cavity may have helped compress material around its edge, and compressed material, if it becomes cold and dense enough, can begin to collapse under its own gravity. This is where the story changes shape. The space around us is not just the inside of an old wound. It is part of a larger cycle in which stellar death can help prepare the conditions for stellar birth. The massive stars that carved the bubble are gone, but the matter they pushed may have helped organize the nurseries where younger stars are forming now. That does not mean every nearby young star was directly caused by the local bubble in a simple one-to-one way. Nature is rarely that clean. Star formation depends on density, turbulence, cooling, magnetic fields, gravity, and the prior structure of the gas. But the spatial relationship is striking. Many nearby stellar nurseries appear arranged around the bubble's surface, as though the cavity did not merely remove material from our neighborhood, but helped shape where material gathered. Absence becomes part of architecture. This is an important renewal point, because it prevents the documentary from becoming only a story about emptiness. The local bubble is not simply a void, it is a contrast. Thin inside, denser around parts of its boundary, hot and diffuse in the cavity, cooler and more substantial in surrounding clouds, ancient in origin, but connected to young stars, quiet to the eye, but active in its consequences. The Milky Way builds structure through these contrasts. Gas that is spread too evenly may not collapse easily, but gas that is pushed, shocked, stirred, cooled, and gathered can form denser regions. Gravity works best when material has already been concentrated. A shell of swept-up interstellar matter can become a place where new collapse begins. In this way, The violence of massive stars does not simply tear the galaxy apart. It helps texture it. It makes edges, walls, filaments, and cavities. These are not decorative features, they are conditions. A star-forming cloud is not just a cloud that happened to sit somewhere in space. It is the result of history. Something allowed gas to gather, something helped it cool, something shaped its motion, something changed the balance between pressure pushing outward and gravity pulling inward. When that balance tips far enough, the cloud fragments. Dense pockets form. Protostars begin to grow inside the dark material. A star is born not because space is empty, but because space is uneven. The local bubble makes that unevenness local. It suggests that our neighbourhood is part of a broader feedback system. Stars form from gas. Massive stars then alter the gas around them through radiation, winds, and explosions. Their deaths inject energy and heavy elements into the interstellar medium. That energy clears cavities and compresses shells. Later generations of stars may form along those structures. The galaxy becomes a loop, not a collection of separate events. This is the hidden mechanism behind the emotional image of a galactic scar. A scar is not just damage, it is tissue changed by an event. It has shape because something happened there. It marks the place where the past altered the present. The local bubble is similar, though on an incomparably larger scale. It is not alive, not wounded in a human sense, and not healing with intention. But it is a region where the Milky Way's material has been rearranged by earlier energy. The scar has edges, and along some of those edges, stars are being made. That is not poetic exaggeration. It is the physical consequence of matter being moved into new conditions. The galaxy recycles through force. It does not preserve every structure gently. It breaks clouds apart, compresses others, scatters atoms, gathers dust, heats plasma, cools gas, and lets gravity work where the conditions allow. The sun is not the author of that larger structure. It is a traveller inside it. This distinction matters because it keeps the story honest. It would be tempting to make the local bubble feel as if it were built around us. It was not. The sun is simply inside it now. The bubble is younger than the solar system. Earth and its life were already ancient before this particular local cavity began taking shape. The supernovae that helped create it were not events in our planetary story in any direct human-centered sense. They were galactic events, and we occupy their aftermath. That is more unsettling than a human-centered version. It means our cosmic neighbourhood is not arranged with us in mind. It is the result of processes that began before our species, before our genus, before anything like human thought existed. And yet, those processes define the environment around us today. We live inside a structure we did not notice for most of our history, made by stars we never saw, whose effects became legible only after we built instruments precise enough to map what eyes could not. This is the strange intimacy of astronomy. The events are vast and indifferent, but the evidence is local. A faint particle measurement near Earth, a slight dimming of starlight by dust, a star's distance measured with precision, a pattern of young stellar groups arranged around an invisible boundary. The scale is enormous, but the clues arrive through instruments built by hands. There is another reversal here as well. Nearby does not mean simple. A distant galaxy can sometimes be described by its overall shape, brightness, and redshift. The local interstellar medium demands detail. It surrounds us in every direction. It contains overlapping structures. We observe it from inside. It is partly transparent. Its gas is patchy. Its magnetic fields are difficult to trace. Its history must be inferred from fragments. The closer environment, the one we might expect to know best, becomes difficult precisely because we are embedded within it. A person inside a forest cannot see the forest's full outline. A person inside a cloud cannot see its edges clearly. A civilization inside a local bubble must build its map from shadows, motions, particles, and distances. The local bubble is therefore both a place and a problem. As a place, it is the cavity around us, low density, irregular, and connected to surrounding interstellar structures. As a problem, it asks how massive stars reshaped this region, how many explosions were involved, how the bubble expanded, how it interacts with nearby cavities, and how its shell relates to star formation. Each answer depends on better maps, better models, and better measurements. The same is true at the smaller scale of the heliosphere. It is both our solar shelter and a scientific problem. How exactly is it shaped? How does the interstellar magnetic field bend around it? How does the solar cycle alter its boundary? How do particles cross or return from the edge? Why did IBEX see a ribbon? What will IMAP reveal with sharper measurements? The story renews here because the two bubbles begin to mirror each other without becoming the same thing. One is made by the sun, maintained now, breathing with solar activity. The other was made by massive stars, inherited now, evolving over millions of years. One protects and filters the planetary system. The other forms part of the larger cavity through which the sun is moving. One is our immediate solar envelope. The other is our local galactic room. Both are shaped by pressure. Both are revealed indirectly. Both remind us that space becomes structured when energy meets matter. This layered view changes how the viewer should imagine the night sky. The stars are not simply points beyond a void. They are embedded in a medium that remembers explosions and organizes future stars. The dark spaces between constellations are not nothing. They contain gas too thin to see, dust too faint to notice, fields too subtle for senses, and structures too large to fit inside a single glance. The sky is not a ceiling of lights. It is a cross-section through a moving environment. That environment has consequences for exploration, for stellar birth, for planetary protection, and for the history of matter. It shapes what reaches the solar system from the galaxy. It shapes how the sun's bubble responds. It tells us that the nearest darkness has a past. It tells us that emptiness can be a product of events, not the absence of them. And it leaves one deeper question open. If the space around us was shaped by past stars, and if the sun is only passing through this arrangement, then our current cosmic neighborhood is temporary. The heliosphere will not always meet the same interstellar conditions. The local bubble will not remain unchanged forever. The sun's path will carry it through new regions, new densities, new pressures, and new relationships with the galaxy. Home, at this scale, is not a fixed location. It is a moving condition. That moving condition has consequences. Some are practical, close to human technology. Some are planetary, unfolding through layers of protection. Some are galactic, written into the way stars and gas shape one another over millions of years. The space around us is not merely scenery beyond the atmosphere. It is part of the operating environment of Earth, spacecraft, and every future attempt to move farther from the sun. Begin with the most immediate consequence: radiation. The galaxy sends high-energy particles through interstellar space. These galactic cosmic rays are not light, but charged particles, often protons or atomic nuclei, moving at tremendous speeds. Their origins are complex and include violent astrophysical processes, such as supernova remnants and other energetic environments. By the time they reach the solar system, they are no longer carrying a neat address label, but they do carry energy, and that energy matters. The heliosphere changes how many of them reach the inner solar system. It does not block them completely. That would be the wrong image. Instead, the sun's magnetic field, carried outward by the solar wind, helps scatter and modulate incoming cosmic rays. When solar activity is stronger, the inner heliosphere tends to be better at reducing some of the galactic cosmic ray flux near Earth. When the sun is quieter, more can penetrate. The result is not a locked gate, but a variable filter. Earth has further protection. Its magnetic field deflects many charged particles. Its atmosphere absorbs and transforms radiation before it reaches the ground. A cosmic ray striking the atmosphere can create a shower of secondary particles. Most people never notice this happening, yet it is part of the constant exchange between Earth and space. The planet is not isolated from the galaxy. It is protected within layers, and those layers interact. For astronauts, the protection becomes thinner. A spacecraft in deep space cannot rely on Earth's atmosphere. Beyond the strongest shelter of Earth's magnetic field, radiation becomes one of the major obstacles to long-duration human exploration. Solar energetic particles from eruptions can arrive in dangerous bursts. Galactic cosmic rays are harder to shield against because of their high energies. Understanding the heliosphere is therefore not only a question of cosmic geography, it is part of understanding the radiation environment through which future missions must travel. Space weather is the nearer face of this problem. Solar storms do not need to be apocalyptic to matter. A strong eruption from the Sun can disturb Earth's magnetic environment, increase currents in technological systems, affect satellite operations, disrupt communication, and brighten auroras. Modern civilization has extended itself into near-Earth space, and that means we live partly inside the Sun's weather. Satellites, navigation signals, power grids, aviation routes, and human spaceflight all depend on understanding the conditions created by our star. The same Sun that makes Earth habitable also makes space around Earth active. This is not a contradiction. It is the nature of living near a star. The Sun gives light and heat, drives climate from above, powers photosynthesis, and anchors the planets gravitationally. But it also emits plasma, magnetic fields, ultraviolet radiation, X-rays, and eruptions. The habitability of Earth depends not on the absence of solar force, but on the fact that Earth has the right protections and distance to receive some forms of that force while surviving others. Nearby space is therefore not neutral, it is moderated. Earth's atmosphere moderates sunlight. Earth's magnetic field moderates charged particles. The heliosphere moderates the galaxy. Each layer reduces, redirects, absorbs, or transforms part of what comes from outside. The planet we know exists inside a nested set of filters. This nested protection also affects how we interpret other worlds. Mars shows what happens when protection differs. It is not simply that Mars is farther from the Sun or smaller than Earth. Its lack of a strong global magnetic field today and its thin atmosphere mean its interaction with the solar wind is different. Over billions of years, atmospheric escape helped change the planet's surface environment. The story of Mars is not caused by solar wind alone, but solar particles are part of the long history of how a once more active world became the cold, thin-aired planet we observe now. Venus offers another contrast. It has no Earth-like global magnetic field, yet its thick atmosphere interacts with the solar wind in its own way, forming an induced magnetosphere. Jupiter offers the opposite extreme, a vast magnetic domain, powered by a rapidly rotating giant planet and filled with particles from its moon Io, embedded within the broader solar environment. Every planet teaches a different version of the same lesson. Space is not empty around worlds. It is an interaction zone. This matters for exoplanets too. When scientists ask whether a planet around another star might be habitable, they can not only ask whether it sits at the right distance for liquid water, in a simplified model. They must ask what kind of star it orbits, how active that star is, what particle radiation reaches the planet, whether the planet has an atmosphere, whether it has a magnetic field, how old the system is, and how stellar activity changes over time. A world can be in the right temperature zone and still face hostile space weather. Another may survive because of atmosphere, magnetic protection, or sheer distance. The local space around a star becomes part of the planet's fate. Our own heliosphere is one example of a stellar astrosphere, the bubble created by a star's wind as it moves through interstellar space. Other stars have their own wind-blown environments, though they are much harder to measure. By studying ours up close, scientists gain a physical reference for how stars interact with their surroundings elsewhere in the galaxy. The Sun becomes both home and laboratory. The consequences extend outward to star formation. The local bubble's surrounding shell, with its relationship to nearby stellar nurseries, suggests that large-scale stellar feedback can organize where new stars form. That means our local cavity is not only relevant because we happen to be inside it, it is relevant because it shows a larger galactic principle. Stars alter the medium that later makes other stars. Feedback is not a side effect, it is part of the galaxy's machinery. A galaxy without feedback would be a very different kind of system. If gas simply collapsed wherever gravity allowed, star formation might proceed too quickly or too smoothly. But real galaxies are turbulent. Massive stars heat and disrupt clouds. Supernovae drive shocks. Gas is lifted, compressed, dispersed, and recycled. Magnetic fields and cosmic rays add more complexity. The result is a balance, not a perfect equilibrium, but a restless regulation. Stars form, then reshape the conditions for future star formation. The local bubble lets us see that regulation close to home. The bubble's interior is less dense, while material around its edges can be denser. Nearby young stellar groups appear connected to those swept-up regions. That does not make the local bubble the only cause of nearby star formation, but it places our surroundings inside the broader cycle of galactic ecology. The deaths of massive stars cleared space and may have helped gather matter where new stars could emerge. This consequence has a quiet emotional weight. The darkness around the Sun is not just a pause between objects, it is a shaped interval in a cycle. The thinness here and the density there are related. The cavity and the cloud belong to the same history. Even absence can participate in creation when it is produced by the movement of matter. There are also consequences for how we define home. A home is usually imagined as stable. A house stands in one place, a city has borders, a country sits on a map. Earth feels like the center of lived reality because gravity holds us to its surface and the sky returns each night. But the real cosmic home is mobile and layered. Earth moves around the Sun moves through the local bubble. The local bubble belongs to a changing Milky Way. None of these layers is fixed in the way human language prefers. That does not make home less real. It makes it more precise. We are not simply on Earth. We are inside Earth's atmosphere, under Earth's magnetic field, inside the solar wind, inside the heliosphere, inside a local interstellar cavity, inside the galactic disk. Each layer has consequences for what reaches us, what protects us, what we can measure, and what we misunderstand when we look upward and see only quiet. The space near us teaches that environment is not always something the body can feel. It can be a magnetic field shaping particles no eye can follow. It can be a cosmic ray shower beginning high above the atmosphere. It can be a dust grain from interstellar space crossing the planetary system. It can be a cavity hundreds of light years wide, too thin to see, yet structured enough to guide scientific maps. It can be a boundary beyond the planets, where two kinds of space meet. The consequence of understanding this is not fear, it is orientation. The universe becomes less like a collection of distant objects, and more like a set of connected systems. The Sun is connected to the galaxy through the heliosphere. Earth is connected to the Sun through space weather. Nearby star formation is connected to past supernovae through the local bubble. The local environment is connected to the future of exploration through radiation and particles. Nothing here requires exaggeration. The truth is already large enough. The space in our immediate proximity is not waiting to attack us, and it is not empty enough to ignore. It is the outer context of our planet, the boundary condition of our star, and the local memory of the Milky Way. It affects machines before it affects bodies, instruments before it enters ordinary experience, and scientific maps before it becomes part of public imagination. But once it is understood, it changes the way nearby feels. Nearby is no longer just the Moon, Mars, or the next planet outward. Nearby includes the invisible wind around the Sun, the porous edge crossed by Voyager, the interstellar atoms moving through that edge, the local bubble that surrounds our region of the galaxy, and the old explosions that helped make it. The consequence is a quieter, deeper kind of belonging. We belong to Earth, but Earth belongs to a solar environment. The solar environment belongs to a local galactic structure, and that structure belongs to the long, unfinished circulation of matter between stars. The best way to understand our local space is to compare it with places that look similar only from a distance. Around every star there is some kind of environment. A star is not simply a bright object sitting in vacuum. It releases radiation. Many stars release winds, Some flare violently, some are quiet. Some are young and surrounded by thick disks of gas and dust. Some are old and moving through sparse interstellar regions. Some are massive enough to reshape whole clouds before they die. The Sun is one example in a much larger family. But it is the only one whose surrounding bubble we can study from the inside. That makes the heliosphere both ordinary and rare. Ordinary, because stars interacting with interstellar material is a normal galactic process. Rare, because we have spacecraft, particle detectors, and direct measurements from within this one. We can ask detailed questions here that would be almost impossible around another star. We can measure the solar wind near Earth. We can track solar storms. We can follow charged particles through the inner solar system. We can detect interstellar neutral atoms entering the heliosphere. We can compare Voyager's boundary crossings with particle maps made closer to Earth. Other stars may have astrospheres, their own versions of wind-shaped bubbles, but from our distance, they are difficult to see. Sometimes astronomers infer them indirectly, through how stellar winds interact with surrounding gas, or through subtle signatures in ultraviolet observations. But no other stellar bubble is accessible the way ours is. The Sun gives us a laboratory for understanding how stars carve space around themselves. And it also gives us a warning against assuming every star's neighbourhood feels like ours. A young active star can flood its surroundings with stronger flares, radiation and particle events. A red dwarf can have a habitable zone so close to the star that any planet there may face intense stellar activity and tidal locking. A massive star may live in a turbulent region of hot gas, winds, and nearby star formation. A star passing through a denser interstellar cloud may have a more compressed astrosphere than the Sun has now. The space around a planet depends not only on distance from its star, but on the star's behaviour and the medium around the system. So our local environment is not a universal standard. It is a case study. Compare it with the inside of a dense molecular cloud. There, gas and dust are thick enough by interstellar standards to block visible light and hide young stars inside dark material. These clouds are still sparse compared with Earth's atmosphere, but they are dense enough for gravity, cooling, chemistry, and turbulence to matter in a different way. Stars are born in such regions. Their newborn radiation eventually begins to destroy or reshape the material around them. A planet forming inside that environment would have a very different cosmic neighbourhood from Earth's current one. The Sun is not inside such a dense cloud now. It sits in a relatively low-density cavity. That matters. If the solar system were moving through a much denser interstellar region, the heliosphere might be compressed. More interstellar material could enter the planetary region. Cosmic ray modulation might change. The details would depend on the cloud's density, ionization, magnetic field, and the Sun's activity. This is not a claim of immediate danger. It is a reminder that the heliosphere is conditional. Its present size and shape are not guaranteed by the Sun alone. They are produced by the encounter between the Sun and its surroundings. Compare our local bubble with other superbubbles in the Milky Way. Some regions of the galaxy contain enormous cavities blown by clusters of massive stars. In those places, the scale of stellar feedback is more obvious. Hot gas fills cavities, shells expand, young stars gather along edges, clouds are torn apart or compressed. The local bubble is modest compared with the largest structures, but it belongs to the same family of processes. It is a nearby, readable example of how massive stars sculpt the interstellar medium. Because we are inside it, however, it feels less dramatic than the glowing nebula in a telescope image. That is partly an illusion of perspective. A nebula is beautiful because we see it from outside, or at least from far enough away to frame it. The local bubble surrounds us, so it cannot be seen as a single object. It does not hang in the sky like Orion. It has to be reconstructed through measurements. If we could step hundreds of light years away and map it from outside, perhaps its cavity and surrounding walls would feel more intuitively real. But astronomy rarely gives us the viewpoint we want. It gives us the viewpoint we occupy. The Orion Nebula offers a useful contrast. There, stars are actively forming inside a bright, sculpted region of gas and dust. Ultraviolet radiation from young massive stars lights and erodes the surrounding material. The scene is visually dramatic because the gas is dense enough and energized enough to glow. The local bubble is different. It is not a bright nursery. It is a cavity, an absence surrounded by structures. Its drama is not illumination, but arrangement. One shows birth happening visibly. The other shows how past death shaped the conditions around us. Compare the local bubble with cosmic voids on much larger scales, and the distinction becomes even sharper. A cosmic void is a vast region of the universe with fewer galaxies than average, part of the large-scale cosmic web. The local bubble is not that. It is not a void between galaxies. It is not evidence that we live in some special, empty region of the universe. It is a local interstellar cavity inside the Milky Way, shaped by stellar processes. Confusing those scales would distort the science. The word bubble here belongs to galactic gas, not cosmology. That distinction protects the story from false grandeur. The local bubble is enormous to us, but small to the universe. It matters because it is our environment, not because it is the largest structure in existence. Its power lies in proximity. The same way a valley matters to a village more than a mountain range on another continent, the local interstellar cavity matters because it is the region through which the Sun is moving now. Compare nearby space with the space between galaxies, and another misconception breaks. Intergalactic space is generally far emptier than the interstellar medium inside a galaxy, though even there matter exists. Diffuse gas, dark matter, radiation, magnetic fields in some regions, and the faint structure of the cosmic web. But our local environment is not intergalactic emptiness. We live inside a galaxy's disk, where gas, dust, stars, stellar remnants, and magnetic fields create a much richer medium. The darkness outside the solar system is galactic darkness, not absolute nothing. That difference matters because it keeps the scale honest. The Sun's neighbourhood is not isolated from the Milky Way, it is embedded in it. Nearby stars also give context. Alpha Centauri, Proxima Centauri, Barnard's star, Sirius, and other local stars are not sitting in identical conditions. They have their own motions, ages, stellar winds, and planetary possibilities. They move through the same broad galactic neighbourhood, but each star's immediate environment is shaped by its own output and its local surroundings. The Sun's heliosphere is therefore one moving pocket among many, part of a loose community of stars travelling through the local bubble and nearby interstellar structures. This comparison prevents the Sun from becoming too special. The Sun is special to us because Earth depends on it. Scientifically, it is a middle-aged star with a wind, a magnetic cycle, and a planetary system, moving through a local cavity in the Milky Way. Its importance comes from our access. We can study its environment in physical detail. We can send spacecraft through it. We can measure its boundary. That access turns the ordinary into something profound. The same is true of Earth. Earth is not protected because the universe is kind. It is protected because of a particular combination of distance, atmosphere, magnetic field, planetary mass, chemistry, and solar behavior. Change the star, change the planet, or change the surrounding medium, and the story changes. Habitability is not a single line around a star. It is a relationship between a world and its environment. That is why the study of our local space reaches beyond local astronomy. It teaches us how planets are embedded. It teaches us that space around a world is part of the world's long-term condition. It teaches us that the boundary of a star's influence can alter the particle environment through which planets move. It teaches us that galactic structures, though faint and distant by human feeling, are not irrelevant. A generic comparison might say, Earth is small and the universe is large, but that is not the useful lesson here. The useful lesson is that size alone does not decide importance. A few particles per cubic centimetre can shape a boundary larger than the planetary system. A magnetic field too weak to feel can guide charged particles across astronomical distances. A supernova millions of years old can leave a cavity that still defines our neighbourhood. A spacecraft smaller than a room can cross a boundary and change a scientific map. Nearby space is not impressive because it is crowded. It is impressive because it is consequential, despite being thin. This makes it unlike the images that usually dominate space documentaries. There is no giant planet with storms visible from orbit, no black hole bending light into a ring, no exploding star caught at maximum brightness. The local interstellar environment is more subtle. It is a science of traces. It asks the viewer to become sensitive to things that do not look dramatic, but are physically decisive. That sensitivity is the deeper reward. Once it develops, the night sky stops being only a background. The darkness between stars becomes a medium. The solar system stops being only a set of orbits. It becomes a moving bubble. The sun stops being only a light source. It becomes an engine shaping space. The Milky Way stops being only a band of stars. It becomes a working structure of gas, pressure, radiation, and history. The comparison with other cosmic environments brings us back to the same quiet conclusion. Our neighbourhood is not the most extreme place in the galaxy, and that is exactly why it is revealing. It is ordinary enough to teach a general rule, and close enough to measure in detail. It is not empty. It is not spectacular in the usual visual sense. It is the kind of place science has to earn slowly, with instruments that can recognise a landscape made almost entirely of near nothing. What remains unknown is not whether nearby space has structure. It does. The uncertainty lies in the details. The true shape of the heliosphere, the fine structure of the local bubble, the exact history of the supernovae that helped carve it, the way magnetic fields thread through our local environment, and the degree to which changes in that environment have mattered for Earth over deep time. The broad picture has become clearer. The edges are still being sharpened. Start with the heliosphere. It is tempting to imagine that once Voyager crossed the heliopause, the border became known. But two crossings do not define an entire surface. Voyager 1 and Voyager 2 travelled in different directions, and both gave priceless measurements. But the heliosphere surrounds the Sun in 3 dimensions. It changes over time. It responds to the solar cycle. It is shaped by the local interstellar magnetic field. It is influenced by neutral atoms, charged particles, cosmic rays, and the speed of the Sun through the surrounding medium. To map that with only 2 direct paths would be like trying to understand Earth's coastline by walking into the ocean at 2 beaches. The crossings prove that the transition is real. They did not finish the map. The true global shape of the heliosphere remains one of the central questions. Older drawings often showed it with a long tail, like a comet, with the Sun moving through the interstellar medium and leaving a stretched wake behind. That picture may still capture part of the intuition, but modern observations have complicated it. Some models suggest a shorter, more rounded or 2-lobed structure. Others emphasize the role of the interstellar magnetic field, which can shape the boundary in ways that simple fluid pictures miss. The honest answer is that the heliosphere is not yet reduced to one final image. And it may never be a simple image, because it is not a rigid object. It is a dynamic plasma system. Its shape can depend on solar activity, particle populations, magnetic field orientation, and external pressure. A diagram can show an average idea, but the real boundary is alive with variation. That uncertainty is not cosmetic. The heliosphere controls part of the cosmic ray environment in the inner solar system. It tells us how the Sun interacts with the galaxy. It gives us the nearest example of how stellar winds create astrospheres around stars. Knowing its shape is not only about drawing the edge of home, it is about understanding how stars make protective envelopes and how those envelopes respond to interstellar conditions. The next uncertainty lies outside the heliosphere, in the local interstellar medium. We know the Sun is moving through a sparse, partly ionized environment. We know there are nearby cloudlets with different velocities and conditions. We know neutral atoms from interstellar space enter the heliosphere and can be measured. But the exact arrangement of these local clouds is difficult to define. Their boundaries are not sharp. Their densities are low. Their temperatures, ionization states, and magnetic properties must be inferred from indirect evidence. Even the phrase cloud can give a false certainty. A cloud in the interstellar medium is not a floating object with a clean outline. It is a region where conditions differ from neighbouring regions. The transition may be gradual. The cloud may be irregular, stretched, turbulent, or partly blended with other structures. We name these regions because naming helps us think, but the physical reality is messier than the label. That messiness matters for the future of the heliosphere. If the Sun moves into material with different density, temperature, ionization, or magnetic structure, the heliosphere can change. It may expand or compress. The balance of particles entering the solar system may shift. The cosmic ray environment may be altered. The timescales are long, and there is no reason to turn this into immediate alarm. But over astronomical time, the Sun does not remain in the same galactic weather forever. A deeper uncertainty surrounds the local bubble itself. The broad idea is strong. The Sun sits inside a large, low-density cavity in the local interstellar medium, likely shaped by stellar winds and supernovae from massive stars. But the exact geometry of that cavity is still being refined. It is irregular. It may connect to other cavities or tunnels. Its walls are not equally defined in every direction. Its hot gas content, dust distribution, and relationship to surrounding clouds are still active research areas. Mapping it requires solving a difficult inverse problem. We are inside the cavity, looking outward through uneven material. Dust blocks and reddens starlight, but not uniformly. Gas reveals itself through absorption lines, emission, and high-energy observations, depending on its state. Hot plasma may emit X-rays, but those signals can be confused with other foreground or background sources. Stellar distances help, but the material between stars is not always easy to place precisely. Every map depends on assumptions, data quality, and methods. The result is not one perfect shell, it is a structure that becomes clearer as measurements improve. There is also uncertainty in its origin story. Leading reconstructions connect the local bubble to a sequence of supernovae from massive stars over roughly the last several million to tens of millions of years. But how many explosions were involved? Exactly where did they occur? Which stellar groups produced them? How did their shock waves overlap? How did pre-existing clouds and magnetic fields shape the expansion? These questions do not have simple final answers. The past has to be inferred from what survived. The stars that exploded are gone. Their light reached whatever observers might have existed then and passed into history. What remains is motion, structure, chemical enrichment, and the arrangement of gas and young stars. Astronomers run the clock backward using stellar motions, ages, and models of expanding shells. This can produce a compelling reconstruction, but not a perfect replay. That distinction protects trust. A premium science story should never make a model sound like a security camera recording. The local bubble's supernova origin is not a myth, and it is not random speculation. It is a physics-based interpretation supported by multiple lines of evidence. But the details remain model-dependent. Better data can shift the timeline, reshape the shell, or revise the number and locations of the contributing explosions. There is another uncertainty, more delicate: how much the local galactic environment has affected Earth. Nearby supernovae, changing cosmic ray fluxes, interstellar dust, and variations in the heliosphere have all been studied as possible influences on Earth's atmosphere, climate, or biosphere over deep time. Some evidence, such as traces of certain radioactive isotopes in geological records, suggests that nearby supernova activity has occurred within the last few million years. But linking such events directly to specific biological or climatic outcomes is much harder. Earth is a complex planet. Climate has many drivers. Life has many pressures. Geological records are incomplete. Signals can overlap. A cosmic event may leave a trace without dominating the planet's history. It may contribute to a background condition without causing a clear catastrophe. The honest position is neither to dismiss the galaxy as irrelevant, nor to claim every major turn in Earth's story came from space. The galaxy can touch Earth without writing the whole script. That sentence matters because it resists both extremes. It avoids the comfortable illusion that Earth is sealed away from the universe. It also avoids the sensational idea that invisible cosmic forces secretly explain everything. Reality is subtler. Earth is embedded, protected, exposed, and self-regulating in different degrees at the same time. There are also unknowns in the magnetic field around us. Magnetic fields in space are difficult to visualize, but they are crucial. They influence how charged particles move. They shape plasma boundaries. They affect the heliosphere's interaction with the local interstellar medium. They may help define the IBEX ribbon and influence the flow of cosmic rays. Yet measuring a weak magnetic field across interstellar distances is not like placing a compass in a room. Scientists infer its direction and strength from polarized starlight, particle behavior, dust alignment, and other indirect tracers. The field is real, but our view of it is partial. This is why the next generation of measurements matters. New particle maps, better dust reconstructions, improved stellar distances, more sensitive X-ray observations, and continued modelling can all sharpen the picture. Some answers will come from spacecraft near Earth, some from distant probes, some from telescopes measuring stars and gas, some from computers testing which physical histories could produce the structures we observe. The neighbourhood will not become simple. It will become more specific. That is the right expectation for real science. The first version of a discovery often replaces blankness with a shape. Later work replaces the shape with texture. Then texture becomes motion. Then motion becomes history. The local bubble began for many people as a name, then became a cavity, then a mapped structure, then a possible organizer of nearby star formation. The heliosphere began as an expected boundary, then became a crossed frontier, then a complex system with ribbons, particles, asymmetries, and unresolved geometry. The unknowns are not holes in the story, they are where the story is still alive. The space around us is now understood well enough to break the old illusion of emptiness, but it is not understood so completely that wonder has been exhausted. We know we are inside nested structures. We know the sun is pushing against the galaxy. We know ancient stars helped shape the larger cavity around us. We know invisible particles and fields carry messages across the boundary. What we do not yet know is the exact form of the room we are in. And perhaps that is the most honest image. A civilization inside a transparent, moving, ancient structure, finally learning how to measure its walls. The human perspective begins with a strange humiliation. We learned the shape of continents before we learned the shape of the space around the sun. We crossed oceans, drew coastlines, named winds, measured mountains, drilled into the crust, and sent machines to other planets. We photographed galaxies whose light began travelling before complex life existed on land. Yet the local environment surrounding our own star remained, for most of history, invisible enough to be mistaken for absence. This is not because humans were careless. It is because ordinary senses evolved for dense matter. Eyes evolved for light reflected from surfaces. Ears evolved for vibrations in air or water. Skin evolved to feel pressure, temperature, texture, and injury. None of these senses is built to perceive a plasma boundary beyond the planets, a magnetic field stretched through interstellar gas, or a cavity hundreds of light years across. The space near us does not announce itself in the language of the body, so the body calls it nothing. Science had to invent new senses. A magnetometer becomes a way of feeling invisible fields. A particle detector becomes a way of counting impacts from distant regions. A radio antenna becomes a way of hearing plasma waves without sound. A telescope measuring starlight becomes a way of finding dust between stars. A spacecraft far beyond the planets becomes a fingertip touching the edge of the sun's influence. That is one of the deepest human achievements in this story. We did not simply discover more objects, we expanded the definition of perception. We learned to sense conditions that no animal body could naturally feel. The heliosphere and the local bubble are not obvious landscapes. They are instrument-made landscapes, not because they are artificial, but because only instruments can translate them into human knowledge. This changes what exploration means. The old heroic image of exploration often involves arrival, stepping onto land, reaching a summit, planting instruments on a surface, seeing the destination directly. But nearby space teaches another kind of exploration. Sometimes we do not arrive at a place in any satisfying visual way. Sometimes we infer it from a changed particle count. Sometimes a boundary is crossed without a camera showing anything. Sometimes the great discovery is not an image, but a transition in data. Voyager crossing the heliopause was not a cinematic moment for the spacecraft. There was no glowing gate, no audible crackle, no sudden view of interstellar space. The machine continued moving through darkness, almost exactly as before, while its instruments registered that the environment had changed. The drama belonged not to the eye, but to interpretation. That is a mature kind of wonder. It asks the viewer to care about reality, even when reality does not perform for them. It asks us to accept that the universe is not obligated to look dramatic in order to be profound. A boundary can be historic without being visible. A cavity can be enormous without glowing. A particle can be small enough to ignore and still carry news from the edge of the solar system. This kind of wonder is quieter than spectacle, but it lasts longer. It also makes Earth feel different. The planet is no longer merely a world beneath a sky. It is a protected pocket inside a chain of larger protections and exposures. The atmosphere holds pressure and warmth. The magnetic field shapes charged particles. The sun's wind creates the heliosphere. The heliosphere moderates the galaxy. The local bubble defines the broader cavity around us. Each layer is both shelter and connection. Human life exists in the innermost softness of that arrangement. We live where air is thick enough for lungs, water is stable enough for oceans, temperature is moderate enough for chemistry, and radiation is filtered enough for cells. From that mild surface, space can seem remote, but the mildness is not the default condition of the universe. It is a local outcome, maintained by planetary and stellar circumstances. The fact that the ground feels ordinary is not proof that the cosmos is simple. It is proof that our bodies are adapted to a rare layer of it. This should not turn into sentimentalism. Earth is not precious because the universe cares about it. Earth is precious because conditions that feel ordinary to us are physically specific. Remove the atmosphere and the human world ends. Remove the magnetic field and the radiation environment changes. Change the sun and climate, chemistry and habitability change. Change the outer heliosphere and the flow of some high-energy particles changes. Each layer matters because life is sensitive. The local cosmic environment, therefore, offers a more precise form of humility. It does not merely say, "We are small." That line has become too easy. It says something sharper. We are embedded. We are not outside the systems we study. We are inside them, dependent on them, partly protected from them, partly exposed to them, and only recently aware of them. To understand our location, we have to give up the fantasy of a clean boundary between Earth and space. The atmosphere fades, the magnetosphere stretches, the solar wind fills interplanetary space. The heliopause marks a change in dominance, not an absolute edge. Interstellar atoms enter, galactic cosmic rays arrive, dust passes through. The local bubble surrounds the sun across distances too large for direct experience. There is no single line where home ends and the universe begins. There are gradients. This is a difficult idea emotionally because human beings like borders. We want a door, a wall, a coastline, a final edge. But nature often gives transitions. Shorelines shift with tides. Atmospheres thin with altitude. Magnetic influence weakens with distance. Clouds fade into surrounding air. The solar system, too, is not a room with a clean wall. It is a set of influences that fade, overlap, and give way to other influences. That realization also changes how we think about intelligence. For most of Earth's history, life existed inside the local bubble without knowing it. Dinosaurs, forests, oceans, insects, mammals, microbes, all lived beneath layers of protection and exposure they could not name. Even humans spent nearly all of their history under the same sky, without knowing the solar wind existed. Only in the last tiny fraction of human time Did we build detectors capable of recognizing the sun's larger envelope and the local cavity around it? The universe did not become structured when we noticed it, but our world became deeper. This is perhaps the emotional center of science. Reality has more architecture than experience first reveals. The familiar is not false, it is incomplete. Earth is still Earth, the sky is still the sky, night is still dark. But behind that darkness is a physical environment with pressure, history, and motion. Knowledge does not destroy the ordinary world, it gives the ordinary world hidden depth. There is comfort in that, but not the easy kind. The comfort is not that we are safe forever. It is not that the universe is designed for us. It is not that every unknown will become simple. The comfort is that the unknown can be approached honestly. The space around us seemed like nothing, and then it became a layered system. The boundary of the sun seemed unreachable, and then two small machines crossed it. The local bubble seemed too diffuse to picture, and then maps began to show its walls. Human beings are fragile, but our methods are patient. A spacecraft can travel for decades. A survey can measure 1 billion stars. A detector can count particles no eye will ever see. A model can test how ancient explosions shaped gas we now occupy. Our bodies cannot feel the local interstellar medium, but our instruments can translate it. Our minds cannot naturally imagine hundreds of light years, but mathematics and evidence can hold the scale open long enough for understanding. That is why this subject matters beyond astronomy. It teaches a discipline of attention. It teaches that a place can be real before it is obvious. It teaches that absence may have a cause. It teaches that protection can be partial, boundaries can be porous, and home can be moving. It teaches that the environment of life extends farther than weather, farther than atmosphere, farther than the orbit of the moon. The human perspective is not that we are central. It is that we are local witnesses. From one small planet, inside one star's moving bubble, inside one galactic cavity, we have begun to reconstruct the room around us. We are not outside the picture. We are a tiny instrument within it, learning slowly that the darkness nearest to us has shape. The long-term fate of our local space is movement. Nothing in this structure is permanent, even if its changes are too slow for ordinary human feeling. The heliosphere changes with the sun changes with age, the local interstellar medium changes with motion, the local bubble changes as gas flows, cools, mixes, and meets surrounding structures. The Milky Way itself keeps turning, stirring stars and clouds through a disk that is never completely still. The first future belongs to the sun's own bubble. As long as the sun releases solar wind, it will continue to maintain a heliosphere. The exact size and shape of that heliosphere will shift as solar activity rises and falls, as the solar wind changes, and as the surrounding interstellar environment changes. The boundary crossed by Voyager is not the final form of anything. It is the boundary as measured during a particular era, along particular paths, under particular conditions. Future instruments may find that the heliosphere looks less like the familiar comet-shaped drawings and more like a distorted, magnetically sculpted envelope. They may show that the tail is shorter, stranger, or divided. They may reveal more structure in the way energetic particles move through the outer boundary. They may explain the ribbon seen by IBEX more fully, or complicate it with sharper detail. The map will not become less real if it changes. It will become more honest. A living boundary should not be expected to keep one pose. Beyond the heliosphere, the sun's path through the galaxy will slowly carry it into different surroundings. The local cloud around us will not last forever as our immediate medium. Over long timescales, the solar system may move into regions with slightly different density, temperature, ionization, dust content, or magnetic field direction. The heliosphere will answer those changes. If the outside pressure grows, the solar bubble may compress. If the surroundings become thinner, it may expand. If the magnetic field geometry changes, the boundary may warp differently. Most of this will unfold far too slowly to become human drama. It is not a forecast of catastrophe. It is simply the natural consequence of a star moving through a structured galaxy. The solar system's outer conditions are not fixed because the galaxy is not fixed. In that sense, our cosmic address has weather and climate. The solar cycle is weather. Years of changing activity, storms, particle events, magnetic shifts. The sun's journey through different interstellar regions is climate. Long background changes in the medium that surrounds the heliosphere. The local bubble is older geology, the inherited landscape made by past stars, evolving across millions of years. And the Milky Way's rotation is tectonics on a galactic scale, carrying stars through spiral features, clouds, cavities, and associations. These comparisons are imperfect, but useful. They show that time has layers, just as space has layers. The sun itself will also change. It is a middle-aged star now, stable enough for Earth's long biological history, but not eternal. Over hundreds of millions and billions of years, its luminosity will gradually increase. Far in the future, this will matter more for Earth than the precise structure of the local bubble. The inner solar system's fate is tied most strongly to the aging sun. Eventually, the sun will leave its current main sequence life, expand into a red giant, lose mass, and become a white dwarf, surrounded by the remains of its system. That future is not near on human timescales, but it gives the local environment an ending that is different from the local bubble's ending. The heliosphere as we know it is a structure of the present sun. When the sun changes radically, its wind, radiation, and surrounding bubble will change too. A red giant sun will shed material into space. Later, the white dwarf will no longer maintain the same solar wind environment that shaped the planetary era. The bubble around the sun is therefore not only conditional on external pressure, it is conditional on the star's life stage. The shelter has a lifetime because the star has a lifetime. The local bubble's future is harder to picture because it is not one object with one destiny. It may expand, merge with neighbouring cavities, cool, fragment, or be reshaped by later stellar events. New supernovae elsewhere will carve other bubbles, stellar winds will open smaller cavities, gas will flow through tunnels and shells, dense regions will collapse into stars. The Milky Way will keep erasing and rewriting its interstellar architecture. On large enough timescales, the present local bubble will lose its identity. Its walls may blend with other structures, its hot gas may cool or mix, its boundaries may become less distinct. The star-forming regions now associated with its shell will evolve. Young stars will age. Some massive stars among them may one day explode, pushing new shocks into the surrounding medium, beginning another cycle of clearing and compression. The cavity around us is not the last word. It is one temporary expression of the galaxy's recycling. That is the deep time escalation of the story. Nearby space is temporary at every scale. Earth's atmosphere changes over geological time. The heliosphere changes with the sun and the surrounding medium. The local bubble changes as a galactic structure. The Milky Way changes as generations of stars form and die. Even the word nearby changes because the stars themselves are moving. The constellations that seem fixed will distort over tens of thousands of years. Nearby stellar neighbours will approach and recede. Some stars now familiar will drift away. Others will pass closer. The sun's local neighbourhood in a stellar sense is not a permanent group. It is a temporary arrangement of moving lights. The night sky is slow motion. Human beings do not notice because our lives are brief. We inherit a sky and assume it is ancient in its present form. It is ancient, but not fixed. The stars have proper motions, the sun has an orbit, the gas has flows, the cavities have histories. Everything is moving, but not everything moves on the same clock. This is why deep time can feel cold. It removes the comfort of permanence. It tells us that even the largest structures around us are not final. The bubble that surrounds the sun now was not always here. The local interstellar conditions that shape the heliosphere now will not always be the same. The boundary crossed by Voyager will shift. The instruments we build capture an era, not an eternal map. But deep time also gives the story dignity. A temporary structure can still be real. A wave is temporary. A cloud is temporary. A life is temporary. A star is temporary. The fact that a thing changes does not make it less worthy of understanding. It makes understanding more urgent, because the structure is a moment in a longer process. Our local space is one such moment. For a short interval in galactic history, the Sun and Earth occupy a low-density cavity surrounded by the traces of past stellar violence and present star formation. For a short interval, 2 Voyager spacecraft still send faint information from beyond the heliopause. For a short interval, human civilization has instruments capable of recognizing the hidden layers of its address. For a short interval, the space around us can be mapped by minds living inside it. That is not a sentimental thought. It is an exact one. The measurements we make now are measurements of now. The solar cycle now. The local interstellar flow now. The cosmic ray modulation now. The dust map as seen now. The stars at their current positions and velocities. Future astronomers, if they exist, will inherit a changed sky and a changed local medium. Their maps will not be identical to ours. They may look back at our era as one brief slice through the galaxy's motion. The final escalation is not outward to a larger object, but inward into the meaning of change. We often imagine science as the search for timeless facts. Some facts are stable enough to feel timeless: gravity, light, atomic structure, the laws that govern pressure and motion. But the systems those laws create are historical. The heliosphere has a history. The local bubble has a history. Earth's exposure to space has a history. The Milky Way's gas has a history. The laws persist. The landscape changes. That is the colder, deeper realization. The space near us is not a stage built once for the drama of planets. It is a passing condition made by moving stars, old explosions, present winds, weak fields, sparse gas and time. It will continue after us, but not as a monument. It will continue by changing. Voyager will eventually fall silent. Its power will fade below usefulness. It will keep moving, but no longer as a communicating instrument. The heliosphere will continue without being heard from those particular points. The local bubble will continue evolving whether or not anyone maps it. The Sun will continue its orbit. Earth will continue for a time beneath its atmosphere, carrying life inside layers of protection that most living things will never know exist. And beyond all of that, the galaxy will keep recycling absence into structure. Gas will thin here and gather there, cavities will open, shells will compress, stars will ignite, massive stars will die, new bubbles will expand through old ones. The darkness between stars will keep remembering events by changing shape. Our immediate proximity is not an exception to cosmic history. It is one of its current forms. By now, the original image of nearby space has been taken apart. It began as darkness, then it became an environment, then it became a set of boundaries, then it became history. The space around us is not a blank interval between Earth and the stars. It is a layered system, and every layer changes the meaning of the one inside it. Earth's atmosphere is the first mercy. It gives pressure, warmth, water and sound. It lets life treat the surface as ordinary. Above it, Earth's magnetic field shapes charged particles and helps turn some solar disturbance into auroral light instead of direct exposure. Beyond that, the solar wind fills interplanetary space, making the region between planets part of the Sun's extended atmosphere. Farther still, the heliosphere surrounds the planetary system as a vast magnetic and particle envelope. Then the Sun's influence thins. At the heliopause, the solar wind gives way to the surrounding interstellar medium. This is not the end of the Sun's gravity, and not the end of all objects associated with the solar system. It is a different kind of edge, the edge of the Sun's dominant particle environment. Voyager crossed it not by seeing a wall, but by measuring a change in the invisible conditions around it. That crossing matters because it proved something intimate and difficult. Our star has a boundary that can be touched by by instruments. The sun is not only a source of light, it is a maker of space. It pushes outward, carries magnetic fields, shapes radiation exposure, modulates cosmic rays, and forms a moving bubble around the worlds it holds. The planets do not orbit inside nothing, they orbit inside the sun's breath. But the sun's breath moves through something larger. Outside the heliosphere is the local interstellar medium, thin, patchy, partly ionized, magnetized, and structured. It contains atoms, plasma, dust, cosmic rays, and fields. It is so sparse that human senses would call it empty, yet it is physical enough to press against the heliosphere and help shape its boundary. It is the nearby face of the galaxy, not as a photograph, but as material. The galaxy reaches the solar system not as a dramatic force, but as a faint pressure. That is one of the central truths of this story. The local galaxy does not need to be dense to matter. A few particles spread across enough distance can define a medium. A weak magnetic field extended across astronomical scales can influence charged particles. A subtle change in density can alter the size of the sun's bubble. Space is not only shaped by large objects, it is also shaped by thin things that persist. Farther outward, the local bubble gives the whole scene a deeper past. The sun is inside a large, irregular, low-density cavity in the interstellar medium. This cavity was probably shaped by a sequence of ancient stellar winds and supernovae from massive stars. Those stars are gone, but their energy changed the local gas. They cleared regions, heated plasma, swept material into surrounding structures, and helped leave behind the galactic environment through which the sun now travels. The darkness around us is therefore not original emptiness, it is processed space. That phrase is important. The space near us has been worked on, it has been pushed, thinned, heated, stirred, compressed, and reorganized. It has a history that can be read in dust maps, stellar motions, particle measurements, X-ray signals, absorption lines, and the arrangement of nearby star-forming regions. It is not an untouched void. It is the aftermath of stellar activity. And yet, calling it an aftermath is still not enough, because the same forces that clear cavities can help gather material elsewhere. The local bubble's surrounding shell appears connected with nearby regions where stars have formed or are forming. The old explosions did not simply remove matter from one place. They helped arrange matter around the cavity. In places where gas became dense and cool enough, gravity could begin its slow collapse. Destruction and birth are not opposites in the interstellar medium. They are connected phases in a larger circulation. This is the final synthesis. Nearby space is an interface between shelter and exposure, absence and structure, death and birth, present wind and ancient explosion. The heliosphere shelters, but it is porous. The local bubble is empty by comparison, but meaningful by origin. The interstellar medium is thin, but consequential. The sun is stable by human standards, but moving through a changing galaxy. Earth is protected, but not separate. Every earlier illusion fails because it tried to make a clean category. Empty or full, inside or outside, safe or exposed, solar system or galaxy, past or present. But the real environment does not respect those simple divisions. It is made of gradients. Influence fades. Boundaries breathe. Particles cross. Structures overlap. Histories remain active inside current conditions. This is why the space near us is so difficult to imagine. The mind wants an object. The reality is a condition. A planet can be pictured. A moon can be pictured. A nebula can be photographed. But the heliosphere is a moving relationship between outflow and resistance. The local bubble is a cavity inferred from what is missing and where surrounding matter has gathered. The local interstellar medium is a near vacuum that still has pressure, motion, and magnetic direction. These are not objects in the ordinary sense. They are arrangements. And arrangements can be real enough to decide what happens. The arrangement around Earth allows life to exist at the surface. The arrangement around the sun filters part of the galaxy. The arrangement around the local bubble helps define nearby star-forming structures. The arrangement of gas and dust in the Milky Way determines where future stars can ignite. The universe is not only a collection of things, it is a collection of relationships between things, and many of those relationships are invisible until the right instrument is built. That is what makes the evidence so powerful. Voyager did not bring back a picture of a wall, it brought back changing measurements. IBEX did not photograph the heliosphere like a planet, it mapped particles arriving from the boundary. Gaia did not photograph the local bubble's surface directly. It measured stars so precisely that the surrounding dust and young stellar regions could be placed in three-dimensional context. The invisible became physical because different kinds of evidence began to agree. This agreement is the opposite of clickbait mystery. It is slow revelation. The mystery was never that space was hiding a secret from us. The mystery was that our senses were too limited to recognize the environment we already lived inside. Science did not uncover a forbidden truth. It built a better set of eyes. Those eyes show us a local universe that is both calmer and stranger than popular imagination tends to allow. It is not filled with immediate danger. It is not a cosmic trap. It is not a hollow nothing. It is a sparse, structured, changing medium where forces too faint to feel become enormous over time and distance. The emotional residue should be quiet because the truth is quiet. The sun carries Earth through the Milky Way inside a bubble of its own making. That bubble moves inside a larger cavity left by stars that died before humanity existed. Around the cavity, material gathers into regions where other stars can form. Inside the smallest protective layers, on one rocky planet, life has become aware enough to map the structures that surround it. This does not make us central. It makes us situated. And being situated is more precise than being central. It means there is an address, but not a throne. It means there is shelter, but not isolation. It means there is history, but not intention. The space around us was not made for us, yet we live inside its consequences. The original question asked what the space in our immediate proximity is like. The most honest answer is that it is thin, dark, magnetized, particle-filled, dust-laced, pressure-shaped, supernova-sculpted, and still incompletely mapped. It is close enough to affect our star's boundary and large enough to exceed imagination. It is quiet enough to seem empty and structured enough to rewrite the meaning of emptiness. It is not nothing around us. It is the hidden anatomy of home. And so the final image is not a planet, or a spacecraft, or a distant star. It is the darkness around all of them. The darkness that looked empty because we did not yet know how to read it. The darkness between Earth and Mars, between Neptune and the heliopause, between the heliopause and the nearest stars. The darkness inside the local bubble, where the sun moves through a cavity shaped by older stellar deaths. The darkness that is not a surface, not a wall, not a room, but a set of conditions so thin that the body would call them nothing, and so real that instruments can spend decades measuring them. This is where the story ends, but not because the structure ends. It ends because the image has changed. At the beginning, nearby space seemed like the absence surrounding the real things. Earth was real, the sun was real, the planets were real, stars were real. Space was the gap between them. But the gap turned out to have pressure, it had motion, it had particles and dust, it had magnetic direction, it had boundaries that could be crossed and cavities that could be mapped, it had memory. The space near us is not a blank page. It is a palimpsest, written over by the sun's present wind and by the galaxy's older violence. Some of the writing is fresh. Solar storms, shifting magnetic fields, particles moving outward from the sun. Some of it is ancient by human standards. The local bubble's cavity, the shells of swept-up gas, the arrangement of nearby stellar nurseries. Some of it is still being written now, as the sun continues forward and the heliosphere adjusts to whatever the galaxy places in its path. Nothing about this requires spectacle. There is no need to imagine a shining barrier around the solar system. There is no need to turn the local bubble into a cosmic dome. There is no need to pretend that the surrounding medium is a threat waiting just outside the planets. The truth is quieter and more durable. We live inside a sparse environment where tiny pressures become architecture, where faint particles carry news from impossible distances, and where absence can have a history. That is more haunting than a louder version would be, because it means our ordinary sense of place has always been incomplete. A person standing outside at night may feel beneath the sky. A more accurate description is stranger. That person is beneath an atmosphere, inside a magnetic field, inside the solar wind, inside the heliosphere, inside a local interstellar cloud environment, inside a supernova-carved cavity in the Milky Way. They are not looking up from a simple surface into empty space. They are looking outward from the innermost habitable layer of a nested cosmic structure. The body feels only the first layer. Science reveals the rest. The atmosphere presses gently enough to be forgotten. The magnetic field leaves no visible wall, except when auroras trace its disturbances in light. The solar wind passes unseen until instruments register its particles. The heliosphere is too large for any camera to frame from within. The local bubble is too diffuse to glow as an object. Each layer hides by being either too familiar, too faint, too vast, or too transparent. And yet each layer matters. Without atmosphere, Earth would not be the world we know. Without magnetic and atmospheric protection, the surface environment would be profoundly different. Without the sun's steady energy, Earth's climate and chemistry would not support the life we recognize. Without the heliosphere, the radiation environment of the inner solar system would not be the same. Without the galaxy's long recycling of gas and stars, there would be no heavy elements, no rocky planets, no chemistry complex enough to ask what nearby space is like. The chain does not make us chosen. It makes us contingent. Everything familiar rests on conditions that could have been otherwise. A different star, a different planet, a different atmosphere, a different magnetic field, a different local medium, a different stellar history nearby, and the address would change. Life does not exist in a generic universe. It exists in a particular arrangement of forces, protections, exposures, and history. This is why the local environment deserves attention. Not because it is the biggest structure, not because it is the most violent, not because it offers the easiest image for a thumbnail. It deserves attention because it is the part of the universe that surrounds us before any other part does. It is the physical context of our star. It is the outer weather of our home. It is the nearest evidence that the Milky Way is not just a band of light, but a medium through which we are moving. The sun will continue that motion. It will carry the planets onward through the local bubble, through local interstellar flows, through a galaxy that keeps changing around it. The heliosphere will swell and contract, distort and respond. Interstellar atoms will continue to slip inward. Galactic cosmic rays will continue to arrive, filtered but not erased. Dust will continue to drift through. Far beyond the planets, the Voyagers will continue outward, long after their voices fade. Silent artifacts moving through the medium they helped humanity recognize. That silence is part of the ending. One day, Voyager will no longer send measurements back to Earth. The machines will still exist, but they will stop being instruments in the active human sense. They will become objects, cold, drifting, unpowered witnesses to a boundary already crossed. The heliosphere will remain behind them. The local bubble will remain around them for a time. The galaxy will continue without noticing that a species once listened from a rocky planet and learned where the sun's wind gave way. There is no tragedy in that. There is only scale. The same scale that makes human life small also makes human measurement astonishing. A civilization that cannot naturally feel the solar wind built instruments to measure it. A species trapped on the surface of one planet sent machines to the edge of its star's particle domain. Minds that evolved to navigate forests, rivers, deserts, and coasts learned to reconstruct a cavity hundreds of light years across from dust, starlight, particles, and motion. The darkness did not become less dark. It became legible. That may be the most honest form of wonder science offers. It does not turn the universe into a story about us. It does not promise that every structure has meaning in human terms. It does not soften the indifference of scale. It simply shows that reality has layers, and that some of those layers can be understood. The space in our immediate proximity is not empty. It is a moving environment made of almost nothing, shaped by forces too faint to feel and events too old to remember. It is the sun's wind pressing outward, the galaxy pressing back, the heliopause shifting between them. It is interstellar atoms drifting through the boundary. It is dust dimming distant starlight. It is magnetic fields guiding charged particles through darkness. It is a low-density cavity left by massive stars that died millions of years before anyone could name them. It is shelter, but not isolation. It is history, but not memory in any human sense. It is home, but not a home built for us. That final distinction matters. To call the local bubble our home does not mean it belongs to us. It means we belong inside it for now. We are temporary occupants of a moving arrangement. The sun is carrying us through a region made by earlier stars, toward regions we have not yet entered, under conditions that will slowly change long after all present maps are obsolete. The ordinary night sky will remain beautiful without this knowledge. But with it, the beauty becomes colder and deeper. The blackness between stars is no longer a blank background. It is a medium shaped by pressure and time. The sun is no longer only the daytime light. It is a star enclosed in its own vast breath. Earth is no longer only a planet beneath space. It is a living surface buried inside layers of invisible protection. And the space around us is no longer nothing. It is the first universe we actually inhabit. Not the distant universe of galaxies at the edge of vision. Not the early universe reconstructed from ancient radiation. Not the spectacular universe of black holes and exploding stars, though all of those matter. The first universe is the one that begins just above us and continues outward through fading air, magnetic fields, solar wind, interstellar particles, and the great cavity around the sun. It was always there. We were simply late in learning how to see it. Now, when the sky darkens, the emptiness should feel different. Not crowded, not comforting, not threatening. Different in a quieter way. The darkness overhead is thin, structured, and old. It carries the pressure of the sun, the touch of the galaxy, and the afterimage of stars that died before human thought existed. We live inside that afterimage. And the solar system keeps moving,